Good evening, sir.
Yeah, I'm audible.
Yes, sir. Yes, sir.
Just a minute. I will go to my video also.
Yes, sir.
Okay, now my screen is visible.
Yes, sir. It's
I'm
visible.
visible.
Yes, sir.
Okay, just I share my screen so that you can just get an idea.
Sure, sir.
Okay.
Mm. So your screen is visible if you have shared the screen.
It is now visible.
Yes, sir.
And what about the voice?
But it's clear, sir.
Just a minute.
Yes, sir.
Okay. Voice is okay. I have
Yes, sir.
two arrangement. One is desktop, other is laptop. If any issue comes in the laptop, I already will be connected with the another link.
Sir, actually,
मतलब
your
through the
video has
desktop.
been paused now. I think there is some network
Just a
issue.
minute. Just a minute. Just a minute.
Yes, sir.
Maybe network issue may be there. Just a minute. Network is there. Okay. And just video. Okay. Now see
Yes, sir. Yes, sir.
HP
There is
SD
a little
camera.
bit lag between the video, but it's fine.
Now it is okay.
Yes, sir. Perfect.
And audio is also okay.
Perfect, sir.
Okay. So I think we should start by 5:50.
Sir, at 6. Yes, sir. At
6.
6.
Okay. So your schedule
Yes, sir.
is 6 to 7 and then one more question answer, no?
Yes, sir. Yes, sir.
Okay. Because my lecture is about 1 hour and then we will have any query for regarding this so we can discuss post
Yes,
7.
sir.
Maybe 7,
Yeah.
7:10, but actually 7 to 7:15 between 7:10 we will start our questionnaire session.
Yes, sir.
Okay, and how many like actually I just gone through your slides, this your mail. So I think students as well as faculty is also there.
There is a little bit uh disturbance in the voice. The voice is lagging.
Just a minute, just a minute. Just go to audio also. Select microphone. Now, okay.
No, sir. It's still there is some issue in the video and voice.
Just increase the volume. Mhm. Voice is it is okay. Just a minute. Speakers, system, volume, system, speaker, audio. Now, that is okay.
Uh, no, sir. Actually, your video is paused.
Just a minute.
Now fine, sir. Now
Uh,
fine, sir.
is okay?
Yes, sir.
Okay. And there is another like operating the desktop.
So your
In 3 minutes.
so your voice is not clear.
Uh,
So there is some network issue at your place right now.
now, is audible?
No, sir.
Issues, check it out. Otherwise, what I will do is you should just check it out also.
So actually, we are also checking out from our end, but I think we don't have any network issue.
Yeah, okay, I am just running my desktop also so that we can understand if there is a issue from laptop or if it is similar,
Okay, sir.
then it may be from your side. Just a minute.
Yes, sir. Yes. हाँ.
Okay, now
Yes, sir. Now, video is still lagging, but voice is clear now.
just a minute.
This meeting is being recorded.
Now just a minute.
So I think computer will work more better.
That's why.
Adjust.
I just
Okay, I
okay.
muted
I
my
muted my laptop voice.
now it-
Now it is
desktop.
desktop.
Okay, sir.
So it is okay now.
Yes, sir.
PPT is visible or
Yes, sir. PPT is visible, sir.
just a minute. Then I should switch off the laptop. Okay.
Yes, sir. Yes.
Okay. Now we are from desktop. Now I just share my screen.
Okay, sir.
Now just check it out.
Yes, sir. It's visible, sir.
What about the voice?
So voice is also clear.
Okay. So I think we should go with the desktop.
Yes, sir. This will work
Okay.
best.
So let's start by 5:55.
Yeah, sure, sir.
Okay. I've already opened, so it will be remain open. So you just
Okay.
tell me. And who are going to give me the some introductory part? You are or
Yes, sir. We
okay.
will, sir.
Okay. So I think after 10 to 15 minutes we will connect.
Sure, sir.
Okay.
Hello, sir. Good evening.
Yeah, good evening.
I
I
think so.
think 33
You are,
participants have joined.
uh, I think so. 34%.
Okay, okay,
So they usually join by 6.
okay, okay. Ah, six is already there. 1 minute is left. So I think most of the are the students or
I
faculties
think
also.
so, sir. Most of the people are faculty members.
Okay,
20 to 25% are students, and mostly they are from NICMAR only.
okay,
And some of the students are from NICMAR Pune campus.
okay.
Most of them are faculty members only.
So basically, this is the basically Atal sessions which are conducting by your university or the different university throughout the India.
These sessions are being conducted from different people from the different parts of India.
Okay,
And yesterday, we have a session from Dr. Murli Jagannathan. He was from IIT Madras.
okay.
Then I think so. You might be knowing Dr. Ankur Gupta. He is currently in CCEPL.
Yeah,
So first he was in AML ATES. Then I think so. You met him in GLA University also
yeah,
once.
yeah, yeah. Ankur Gupta, I know.
Yes.
So basically,
So
this is meant for only for academia, not for the others like industry or some research.
no, everyone is invited, and to industry people also we have invited. But exactly, I cannot tell who one is from the industry or who one is from academia.
Okay. You have sent the this all the links to the different industries.
Yes, through LinkedIn and various social media profile, we have shared
It,
this thing.
it is on LinkedIn.
Yes, it was on LinkedIn.
So how can I search? Like if I go to LinkedIn.
You have to go to my actually LinkedIn page from where I shared it, and then our faculty members also reposted it.
Okay, just a minute. NICMAR, Delhi NCR. Okay. So I think uh, okay. Some there is another topic which I just seen, and it is posts today or yesterday.
Yours lecture or
My
FDP?
my my lecture.
No. Yours one is posted in only the group WhatsApp group with the members only.
Okay,
Uh,
okay.
yes,
It is not in LinkedIn.
it was not in LinkedIn,
Okay,
but
okay,
yes, we will post it later on.
okay, okay,
Actually, yesterday our students got free by 9:30 p.m.
okay,
and from morning they were having their lectures. So at 5:20, I think so there was their last lecture.
okay, okay, okay. These are the busy schedule. So
Ah, yes, sir. Vikhyat, who is the host today?
Yes, sir, it's me.
Okay, you are taking care of the session.
Yes, sir.
So Vikhyat, I think so we can you can put one message on the WhatsApp group,
Sure, sir.
and you can ask other people also to join fast.
Yes, sir.
normally the timings remains Nakulji is around up to every time it is evening, 6 to 7:30
Yes, sir. For online Atal FDP, it is evening.
evening. Okay,
Only on Saturday it will start at 2 p.m. and
okay,
Saturday we will be having three sessions. So two session is for the people who are outside India people, and
yeah.
their means change in the timing. We have put it them on Saturday, and we have Dr. Naveen BP from NICCR Kolkata on that day.
Hmm.
So else from Monday to Friday it is 6 to 9,
Okay.
six
So
to seven.
there is another lecture after 7:30.
Yes, sir. I think so. Today we have lecture from, I'm not remembering his name. 1 second. It is from DMRA. I think so, Dr. Patel, Mr.
Okay.
Patel.
Okay. Okay. DMRA.
Yes. Now they have opened their that academic division also, na Delhi Metro.
Delhi Metro. Yes. Yes. Acha, they have
So
opened
he
their training institute as well as academia part also.
academy part also. So he is Mr. Anil Patel. He is DGM over there.
Okay.
First he was in, I think so, DMRC. Now they have opened this new segment, DMRA.
Okay. So there, what is the this full form? Delhi Metro Research.
Delhi means that DMRC has become academia or academic.
Okay. Okay.
Others are same.
Okay. So basically, this C has been converted into.
Means you can say Delhi Metro Rail Academia. I think so. Like this, it is.
Okay. So they are contributing with the to the academia and research bodies, whatever the operations, whatever the construction. They are
Yes, yes, yes. They are means doing all these sessions for industry people also over there. And one of our faculty member, Dr. Amit Goyal, he is one of the keynote speaker over there. Dr. Ankur Gupta also usually takes lecture over there.
okay.
So
Okay.
like this, they have different speakers over there, and they are running their own short term type course, 1 or 2 days or 3 days, MDPs we can say.
Okay. 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 So basically, these are from the like mixed blend of industry, academia, and research bodies.
Yes, sir.
Okay.
Like I think so. Tomorrow we have one scientist from BARC also,
Okay.
Doctor Kapilesh Bhargav.
Okay. So it is again it is online because 6 to 9 you are conducting online.
Yes, sir. It will be online. Only in the case of offline FDP, they are allowing for morning sessions.
Okay.
Even though in Atal FDP, if it is offline mode, then they are means there are two industrial visits also.
Okay. Okay. Malab, this program is basically for not only the skill development as well as imparting the practical insights to the faculty and students.
Yes, sir. Yes, sir.
Because while carrying out the field visits or all these, you are taking care of that through the IICT.
Yes, sir.
Okay.
Not in this online one, but if anyone gets this grant for offline FDP, then
Okay.
they have to arrange for this field visit also.
Okay.
I think so, sir. Now we have 70 participants, so we can start. It is, I think so. We are out of time also.
Yeah. Yeah. Yeah.
6:07 it is.
Because
So
already
I
I
think
have my screen is I think visible. My screen is visible.
yes, sir. It is visible, and I think so. You have to convert it into PPT, this presentation mode.
Is it available?
You can see there is the negative sign below
No,
for
just a,
zooming out, and the left
yeah. Yeah.
click
Yeah.
is for
Just a,
this presentation.
just a minute. Again, I share.
Vikyat, I think so. You can start now.
Now see.
No, no, sir. It has gone back. Please press it again.
Okay.
First
No, screen is not visible.
It's
screen is
visible.
visible, but not in the presentation mode.
Okay, just a minute. Now,
Yes, sir.
Yes,
Now
sir.
it's visible.
Now,
okay.
I think so, Vikyat, you can continue from your side. Then you can introduce
Yes, sir.
our speaker today.
So, good evening, everyone. Hearty virtual welcome back to the day 2 of AICT Atal Academy sponsored FDP on digital construction and green design pathways to net zero. We, the Innovation Cell NICMAR Delhi-NCR, are thrilled to host this 6-day program. This FDP is more than just a series of lectures. It is a critical initiative supported by AICTE designed to empower every faculty member, PhD scholar, and PG students with the knowledge to drive in construction, real estate, infrastructure, and project management sectors. Our collective goal is to identify actionable strategies that lead towards achieving net zero emissions in the urban built environment. Yesterday, day one was an extraordinary success marked by enthusiastic participation and deep engagement. We laid the foundational requirements for sustainability. In the first session, Dr. Murli Jagannathan demonstrated how improved contract management is the necessary contractual backbone for green projects. And in the second session, Dr. Ankur Gupta reinforced with the vital need for structural audits to ensure long-term sustainable performance of our infrastructure. Your active participations and excellent questions demonstrated the true commitment of this cause. Today, day two, we shift our focus from management and audits to the two critical pillars of physical built environment, materials, and methods. We expect today's session to be just as insightful, enlightening, and transformative. We have two giants in their respective fields lined up for you today. So we kick off our technical session for the day two with session 3 running from 6 p.m. to 7:30 p.m. The session topic is sustainability, decarbonization, and circularity in cement and construction. The topic is paramount as the production of cement is one of the world's industrial source of carbon emissions found in this sector. It is my immense pleasure to introduce our expert, a professional dedicated to pioneering these essential material level changes, Dr. Sanjay Mundra. Dr. Mundra is a distinguished professional currently serving as General Manager, Technical and the Program Service in charge of the NABL accredited MPI laboratory at the National Council of Cement and Building Materials in Ballabgarh, Haryana. Dr. Mundra brings around 3 decades of rich experience in critical areas such as quality requirements of cements, composite cements, and concrete mix designs. His background is perfectly aligned with our theme. His PhD in civil engineering from MNIT Jaipur focused on sustainable waste management, and his research interests include utilizing sustainable waste building materials in concrete production. He even holds one patent in the area of sustainable concrete composites. He possesses vast experience in the practical execution of special concretes like ready mix, self-compacting, and high-strength concrete. Dr. Mundra is directly involved in shaping national standards, serving as a representative member to the various CED committees of the Bureau of Indian Standards. We are eagerly waiting for his insights into transforming the cement industry towards decarbonization and a true circular economy. Participants, after the session, the platform will be open for the questions. Please prepare your technical questions on sustainable materials and cement alternatives. Now, I invite Dr. Sanjay Mundra to share his expertise. Sir, welcome. The virtual stage is all yours.
Thank you, Mr. Vikrant. And I'm audible?
Yes, sir.
Okay. Thank you, everyone. It is my privilege to share about the sustainability part, circular economy, decarbonization in cement and construction sector. So whatever the input we have given to the government for making policy for the BIS and whatever that we have like done for the various top-notch government institutes like PSUs and government sector. So whatever the research inputs we have given, I will share you. And not only for cement as a binder, we have whatever the new eco-friendly materials which are coming in the construction sector in the next generations. So I will share you. So basically, if we talk about the sustainability is having the so many parameters. When we talk about the circular economy, then we talk about the net zero. That means whatever the GHG emission or carbon emission, we have to drop it down. The 2070 mission as per the PM vision. Then the 5C approach. What are the 5 levers which we will discuss in the next slides? Swachh Bharat mission, that is a very important. Every government institutes or every the notable institutes are doing this Swachh Bharat mission for a 15 days basis. Then alternative fuels and raw materials which we are using in not only cement and construction. The Bureau of Energy Efficiency, the PET scheme, that is the Performance Associated Trade scheme, that we will discuss. Climate change as per the COP27, now COP 28, 29. There every year we are doing this climate change, the conference of party meetings by the PM or the representative of the nation, sustainability reporting, the SDG goals, and the decarbonization, and ultimately the Atmanirbhar Bharat. So we will discuss all aspects. First, we have to understand what are the steps to sustainability. The actual sustainability meaning the whatever the thing, whatever the locally available materials, whatever the available fuels, whatever the available resources, how can we convert into the in the sustainable part, that we will discuss. If we talk about the use of high strength or high performance concrete, the term is very simple, but actually you have to understand how can we procure, how can we produce high performance or high strength concrete. That is a challenge. How can we make a concrete more durable, because our IS 456 now going to be revised from production to performance basis. Replacing Portland cement with supplementary cementing materials, be it is a fly ash. Already we have discussed lot of, and your institute also discussed. All the students know about the fly ash, GGBS, silica fume, metakaolin, natural poisons, rice husk. All these are the replaceable binder, and we are coming with the quaternary binder, not only single binder, then tertiary binder, and then we come to the quaternary binders. Using fillers as a finely divided limestone, finely divided silica, they are the tremendous, all researchers are doing. By using these fillers, they are making more sustainable cement as well as concrete. Using waste materials as a fuel, like the refuse derived fuels, plastic waste. Using recycled concrete, be it is an aggregate or as a concrete part, or be it is a fines, industrial waste as an aggregate. Using the carbon capture utilization storage, that is a very important, because now everybody, every institutes in the world, they are thinking about how can we make a CCU and CCS technologies. So that I will discuss in the roadmap of different worldwide roadmap. Using less water, why it is required, because you have to make a performant concrete regarding the durability part. By incorporating new generation chemical admixture, the PC based admixture from generation 1 to generation 5, improving structural design and building codes, all these are the parts in the focus for the sustainability. Now, when we talk about the circular economy, this idea of circular economy is focused to concept of Atmanirbhar Bharat for long-term sustainable development. And circular economy focus on the concept of reducing, reusing, recycling, and recovering materials in production and consumption process. So ultimately, we have to target how can we minimize the waste on the earth, and how can we make a sustainable construction in the near future. Through industrial processes, the scraps, waste, or byproducts of one industry can become the raw material for another. If you see the line diagram, the linear system, the natural resources converts into products and waste. Similarly, if we go with the circular economy, circular system, we can use all the waste resources again as a natural resources, and we can make earth more sustainable, and we can use the whatever the we are extracting the natural resources, we can use the artificial aggregates and other sources, so that we can make a circular system. The circular economy have the principles derived by design, eliminate waste and pollution, which is we are seeing so many waste in the form of industries, and pollution are there from the factories, circulate products and materials, and the regenerate the nature. And if you see our Prime Minister during his Circular Economy Forum of Asia in Jaipur, March 2025, he underscored the significance of 3R: reduce, reuse, and recycle. Principles in the circular economy in fostering sustainable urban development and resource efficiency. He highlighted India's leadership in global sustainability efforts, including Mission Life, Lifestyle for Environment, and for the Panchamrit goals announced at COP26, reaffirming India's commitment to achieving net zero emission. Most of the world, this developed countries have targeted around 2050 for net zero, and but India is slowly gradually targeting 2070, so that we can achieve the goal of net zero and minimize the global warming level, which is minus 1.5 degrees Celsius. The status of CO2 emission from Indian cement industry, if we talk about, if you see overall installed capacity of cement India in currently 690 million tons, precisely 693, and cement production for year 23-24 was 427 million tons. So there is a huge gap between the production and the consumption. So we have to bridge the gap. And globally, cement sector's CO2 emission is around 7% of the total anthropogenic. while CO2 emission factor 1.12 in 1996, but now with the use of the novel binders, use of the supplementary pozzolanic material, we have to reduce it 0.617 through the indirect emissions also. And if you see in 21, if you see the cement industry is moving towards decarbonization. And cement sector, is considered as a hard to abate sector due to process emissions and during limestone calcination. So these are the important 5 layers of decarbonization. Reduction of clinker factor, because all the GHG emission or CO2 emission comes from the clinker. So how can we reduce the clinker factor? That is the challenge. We are using the novel binders apart from the pozzolanic materials. We have brought the so many new novel cements in the form of LC3, in form of Portland dolomitic cement, in the form of Portland limestone cement, and all other low heat cement we are producing. Alternative fuel and raw materials, AFR, we are using in the cement industry. Earlier we were using the fossil fuels. Now we are converting it all the AFR fuels. I will show you in the next slides. Then waste heat recovery, that is a very, very important. Be it is a closed or open cycle, we have to utilize whatever the waste heat is generated, we have to recover it. Improving the energy efficiency as per the target of B or the government setup. New and emerging technologies such as nanoparticles, geopolymer, and including carbon capture, utilization, and storage. So this is the message in the this coming in the climate innovation of CO COP29. And this is the Global Cement and Concrete Issues. GCC is a body which have the roadmap to net zero. The ultimate aim is to see you by percentage. If I see the saving clinker production, that means the target is 11%. Then for concrete production, it is 11%. Clinker substitution 9%. 5% is part is of your CO2. 6% again around 240 MT of CO2. 36% is carbon capture and utilization. It is a major part which all the world is trying to utilize the capturing the carbon and utilize it in the concrete. And then design optimization, through design optimization we can having the part of 22%. So in part of saving clinker production, we will increase the thermal efficiency. The overall efficiency in India, it is around 7 to 8%, and we have to increase it by 25 to 30% in the next decade, and next in 10 years or 15 years. Saving from waste fuels like using the alternative fuels, use of decarbonated raw materials, and use of hydrogen as a fuel. That is a very important. Now all the industry is thinking we have to replace it, all the fossil fuels with the hydrogen fuel. Then saving cement and binders, the Portland clinker will be now substituted with the various pozzolanic material, and alternative to Portland clinker cements, like I have told you, the LC3 cement, the Portland dolomitic cement, Portland limestone cements, and some other novel binders are coming. And then carbon capture utilization at cement plants. Especially in concrete production, the efficiency can be improved by optimized mix design, optimize of constituent continue to industrialize manufacturing and quality control. So here we are not only targeting the alternative aggregates, the alternative fuels, but regarding the different admixtures also. So reducing the water cement ratio and improving the mix designs, optimization of mix design. Then decarbonization of electricity, that is also another challenge by using the renewable sources from wind and this we can call the solar, and also the new technology, the bio-based. Then CO2 sink recarbonation, natural uptake of CO2 in concrete, and all the different aggregates which having the free lime availability, they are all the industries are targeting to the recarbonation. And efficiency design construction, by briefing the designers to enable optimization, design optimization, construction site efficiency, reuse, and lifetime extension. So this is the another roadmap of SAM Bureau, which having the 5C approaches. You see, their target is to make a up to 25% of process emission can be reabsorbed through recarbonation. Then some thermal substitution rate of concrete saves CO2, recyclability of concrete, admixture to optimize mixed concentrate, carbon capture, low CO2 binders, reducing clinker to cement ratio, alternative fuels, and biodiversity. So all these 5C approach means from clinker to cement, concrete, construction, carbonation. We have to see what approaches we can use as a alternative materials, as a novel binders, as a carbon capture techniques, as a thermal mass substitutions. We can make a proper roadmap till 2070 by using this type of 5C approach. Then another Portland Cement Association having a roadmap to carbon neutrality from clinker, cement, concrete construction, and carbonation. So ultimate aim is we have to think about what is the near solution, what is the long-term solution. If we talk about the near-term solution, you have to replace the raw materials like all the aggregates, all the admixtures, all the different types of fuels with recycled materials, produce low carbon cement blends, optimal design for the lowest life cycle emission. Go to midterm. Midterm means somewhere between around 35 to 45, 2035 to 2045. Increase the use of alternative fuels and use of renewable energy, like I have told you, the wind and solar. Long term, we can make a carbon capture, introduce new cement plants. And carbon capture is basically a good techniques. As I told you, 36% share is to reduce the CO2 emission. But actually, this in India, if you see, it is not. It is they are trying with the making a pilot plant and some industrial scale plant to directly capture from the cement plants the CO2, and then they can utilize it in the construction. And now we talk about the every lever. The first is the substitution of clinker. So this is the overall scenario. When we talk about the blended cement, so it is a sustainable cement, and you can see the comparison of OPC, PPC, PSC, and others. So now from 95 to 2070, you can see the reduction of OPC. It is earlier it was in 95 it was 70%. Now it is only 27%. So 73% is market of blended cement. So you can see how the tremendous changing is going to be changed in the cement industry. And if you see about the latest figure, it is now 25% only. Now substitution of clinker, if we have to see the research, normally for reducing the carbon footprint, so fly ash based cements are all the industry are using GGBS slag cement. This is the new code has developed for LC3. It is very good cement, limestone calcined clay cement. Then limestone based cement, Portland limestone cement, calcined clay and natural pozzolans, and multi blend cements. As I told you, the quaternary blend is also coming with the use of clinker. So ultimately, aim is to reduce the clinker percentage less than 45% or 40%, so that we can make a sustainable or novel concrete by reducing the carbon footprint. Then Portland composite cement is another what we have done in research with the use of fly ash and GGBS. This is the another ternary blend. Recently formulated DI standard on composite cement allows simultaneous addition of fly ash and GGBS to manufacture composite cement with clinker factor as low as 45%. So we have already reached the level of 45%. Our target is 35% or 30%. So we can reduce the CO2 emission in the next 10 to 15 years. Due to limited availability of GBFS, the manufacture of composite cement limited to fewer cement plant. However, this is another challenge because this pig iron industry is having the is only scattered in the part of south and east. So now, if the pig iron industries will try to produce the composite cement, so the challenge is logistic. But every plant is thinking that we will use this cement more, and how can we make economize this particular cement, that is they are targeting. While fly ash and limestone is available in the country, the composite cement comprising of fly ash and limestone intends to use limestone other than cement grade to increase the sustainability in limestone mines life. Now Portland limestone cement is another cement which we have given the data to BIS. The studies were conducted to investigate the feasibility of using different grades limestone development of PLC and first standardization by BIS. The study concluded that limestone addition of appropriate quality and fineness up to 15% could be possible. So based on the various replacement, 5%, 10%, 15, 20, 25, we have find that this optimization can be done up to 15%. And some more research we are doing to make a higher limit of 20 or 25%. This has the potential to reduce specific CO2 emission by 15 kg CO2 per ton of cement if it replaces 12% out of 27% OPC production use. So there is a large CO2 emission can be possible through this use of PLC cement. Then there is a multi-component blend cement using limestone, calcite, and other mineral additives, fly ash and GGBS limestone cement, fly ash and GGBS dolomitic limestone cement, limestone calcite LC3 cement, marble dust and calcite clay cement, and fly ash and calcite clay. So you see, so much research is going on the calcite clay and limestone as a mineral additives, so that we can make a sustainable cement binders for the future generations. This is the specific CO2 emission for various types of cement. You see in OPC, the left side you can see 842 kg per CO2 per ton of cement, while You see the PPC, PSC, composite cement, PCC and PLC is very less. But if you see the composite cement and PSC, it is the carbon emission is very, very less. If you say 338 and 418. So how can you make a multiple blends? You can reduce more CO2 emission from the different cements. And there is another lever, waste collection of cement industry, inventory and characterization of various industrial waste byproducts by enhancing thermal substitution rate from present 7%. As I told you, the thermal substitution rate is only 7%. So we have to target of another in 5 to 10 years by 25%. By utilization of alternative fuels, I will show you the list of alternative fuels which industry is now ready to use and some industries are already using. Enhancement of fly ash addition from the existing limit of 35% to 40% in Portland pozzolanic cement, and utilization of coarser fly ash with the blend of 200 to 250 meters square per kg. As you know, the fly ash earlier we were using with a 300 meters square per kg, but now we are targeting that coarser fly ash is also good for manufacturing purpose. So we are having the target for blend of 200 to 250 meters per kg. This is the status of low carbon cement development. Composite cement based on fly ash and granulated slag. The IS code has already published in 2015 in 16415. Then durability studies were conducted in composite cement based on fly ash and granulated slag, and it is promising. You will see in the next code. Enhancing level of fly ash in PPC beyond 35%. Studies are completed formulation of codes for BIS. Portland composite cement based on fly ash and limestone. These are already completed and under the review of BIS. Portland limestone cement studies are completed formulation of BIS, and Portland dolomitic cement. This is studies under progress. Then multi-component blended cement. These studies are completed for review of formulation of BIS. High MgO clinker, that is another good low carbon cement. By studies are completed under formulation of codes by BIS, and development of geopolymer concrete for application payments and precast concrete production. These are completed already. Code has been developed, and this will be there is another code will be formulated by the BIS for the geopolymer. Lever 2, that is alternative fuels and raw materials for Indian cement industry. If we talk about the different alternative fuels, you can see so many available alternative fuels are available, whether it is rederived fuel, plastic waste, carbon black, ETP, serpent carbon. All these are the list. You can see tire chips, FRP waste, industrial waste, all activated carbon, grease, rest oil. All these are available, and industry is ready to use this type of alternative fuels. These are another list of alternative fuels. In the biofuels are also there, like cow dung, then agriculture waste, rice husk, soya ash, sawdust, mustard husk. All these can be used. Cashew nut. So everybody having the ample opportunity to do research on these type of alternative fuels and using in the cement industry. Then we talk about the alternative raw materials. So you can see waste with mineral frictions contributing to clinker production higher than 50% and oxide constituents more than 80%. So waste byproducts are fly ash from thermal power plants. You can see the 232 million ton production is there, and they can internet application may be used as a 3 to 4% in raw material. The silica and alumina is the main constituent. Steel slag coming from iron steel industry or pig iron industries. You can see by 2030 target is maybe the production may be the 27 million ton per annum. Then we talk about the calcium and calcium oxide, 7% of raw material. Copper slag is another good waste. 2 million ton per annum is the legacy stock. Now we 2% as a raw material can be added as a advantage as a mineralizer. Then you can do PB and zinc slag, that zinc extraction by pyroprocessing, 1 million ton per annum legacy stock. It can be used up to 6% as a raw material for added advantage as a mineralizer. Marble slurry is also another good product. And you can see in Rajasthan there is a huge stock of marble slurry, and 5 to 6 million ton per annum is mineral stock as a raw material can be utilized. And so much research has been done, and 10 to 15% they are replacing as a cement also. Leather sludge is obtained from the leather industry. It is only 0.1 million ton per annum, but it can be used up to 1% as a raw material. These are the another alternative raw material, jarosite, 1 million ton per annum. It is obtained from zinc extraction by hydrometallurgical process. Can be used from 1 to 1.75 as a raw material. Added advantage as a metallizer. Barium sludge is also used for 2 to 3% as raw material. Red mud, 5 to 6% as a raw material. Then aluminum industry having the SPL waste, up to 3% raw material. Electronic catalytic waste from petroleum refinery can be used up to 5%. Aluminum waste up to 1%. And byproducts and 3.5 million ton per stock, but can be used as a 5 to 6% as a raw material. Then ferrochrome slag is a new area of research on different type of waste product. Ferrochrome slag as a concrete aggregate, lime sludge as a raw material for masonry cement, byproduct sand as a raw material, phosphochar, masonry cement bricks, byproduct from soda ash industry as a raw material, kimberlite can be utilized in the different application obtained from diamond mining waste, and byproduct slag can be used as a raw material. So performance improve, and then coming to the improving energy efficiency, the Indian government is improving energy efficiency to various initiatives like the performance achievement rate scheme, standard and labeling, and the energy conservation building code. So these codes are available, but this PET scheme is given to the various industries who are improving their energy efficiency, and they will be being certified. The PET scheme has achieved energy saving of 1.48 million ton oil equivalent in PET cycle 1 in cement sector, which is 81.5% access to the given target saving through implementation of various energy conservation. Similarly, the plants in PET cycle 2 surpassed the energy saving targets and achieved saving of 1.56 million ton oil equivalent, which is around 48% higher than the saving target. So there is a different PET 1, 2, 3, 4, 5. So now they are coming with the PET 3, PET 4, PET 5, and they are making the saving to the energy. Then installation of waste heat recovery. This is very important. Waste heat recovery plants contribute significantly to electrical energy saving in the tune of around 25%. The total installed capacity of waste heat recovery system in the Indian cement industry has increased from 107 megawatt 2011 to 900 megawatt, and till date it is around 1100 megawatt. The total potential of waste heat recovery in Indian cement plants is about 1300 megawatt, and adoption of WHRs is concentrated in these three states. Mostly, you see the waste heat recovery is concentrated in Rajasthan 42%, Chhattisgarh 16%, and MP 11%, because most of the cement plants are lying in these areas. And they together account 70% of total WHR's capacity in cement sector. Now, lever 5, new technologies, renewable energy, and carbon capture. So stage 1, when we talk about, is very important. Now, this is this fifth lever, capturing CO2 in cement industry. So there are various methods of carbon capture: post combustion, oxy-fuel combustion, and pre-combustion. In post combustion, this process extracting CO2 from the flue gases after combustion of fossil fuel. You know the fossil fuels which we are using, the coal, petcoke, all these are the fossil fuels, the natural gas, all these are fossil fuels. Then the method is for post combustion, calcium looping. How can we extract the calcium part? Then chilled ammonia process, then chemical absorption, monoethylamine, and solvent based absorption. These are the techniques. Then another one is the second, the oxy-fuel combustion, supply of complete oxygen in replacement of air. This project has been in the worldwide project is famous LILAC project that is using this oxy-fuel combustion. Pre-combustion, the coal gasification by gray hydrogen. So now we are converting all these different types of fuels in the gray, and then this black, and then the green hydrogens. All these are coming. Then carbon capture technologies. These are the available technologies worldwide. Post combustion carbon capture solvent techniques by RTI International. They have gone up to the level of TRL6, and the cost of CO2 capture is around 3,200 per metric ton of CO2. And they are already demonstrated at a scale. Post combustion by amine-based absorption by Aker, Sol, and Semcap. They have the TRL level of 8. The cost of CO2 is 6,000 per ton of CO2 at a demonstration scale. Then another post-combustion carbonation technique, absorption using amine-promoted buffer salt. This is Carbon Clean UK. They are at a level of TRL 8, 2250 rate per ton of CO2 and demonstration scale. Post-combustion carbon capture by absorption-based capture. This is 7th Canada at a TRL 6, 3750 rate per ton of CO2 and pilot scale. Then calcium looping technique by Clinker, Italy, and ITRI level 8 and at a demonstration scale. Then chilled ammonia process by Samcap, Norway. The organization are doing this technique of chilled ammonia at a level 6 at a pilot scale. Oxy-fuel technology using oxygen in place of air. So in replacing the air by oxygen, ECR and Samcap at a level 8 at a demonstration scale, and direct separation of calcination of CO2 from combustion of CO2, that is Salix, Lilac, 7 TRL level and at a demonstration scale. Now, what is the role of CO2 mineralization in decarbonization of cement production? So, CO2 mineralization or mineral carbonation process storage of CO2 in the form of carbonates of calcium and magnesium. As you know, all the different aggregates, alternative aggregates having the leaking of calcium and magnesium ions. So, how can we trap this CO2 from the your different plants? And by increasing the CO2, we can convert in the calcite and magnesite. Calcium magnesium carbonates are poorly soluble in water, thermodynamically stable, and thus provide permanent storage solution of CO2. The main advantage of mineralization technology is that the flue gases from the cement plant can be directly used for CO2 sequestration. Method of CO2 mineralization mimics naturally occurring weathering process. This is a spontaneous reaction that needs to be accelerated with a small amount of energy. This is the carbonation of industrial solid residue. So you can see the list of so many waste are available. You can ready to get the mineral carbonation technique. The blast furnace slag, LD slag, electric arc furnace slag, copper slag, carbide sludge, recycled concrete aggregates, paper mill waste, biomass ash, incineration bottom ash, fly ash from thermal power plant, cement kiln dust. So there is a lot of space for the researcher to do the research by different using different combination or single aggregate. So it can be they can replace all the natural aggregate with this type of aggregate by mineralization technique. Then technology of mineralization of CO2 in concrete. These are the good organization who are doing this mineralization part. Carbon Cure, they are doing the earliest carbonation, higher strength by injecting CO2 in fresh concrete. Carbonate aggregates, accelerated carbonation, forming aggregates from fly ash, red mud, soil by absorbing CO2. This is the carbon concrete composite C3, new concrete, carbon fibers plus high performance concrete. Carbicrete, they are doing the mineral carbonation by forming limestone by passing CO2 into slag and using it in concrete. CO2 concrete, mineral carbonation, forming limestone by passing CO2 into slag and using it in concrete. Fast carb, accelerated carbonation of recycled concrete aggregate. RCA is available in India also 150 million ton to 200 million tons. They can be used as a accelerated carbonation technique. And Recibaton, they are completing recycling of deconstructed concrete. This is the eco-friendly construction material available. So the main aim is to reduce the carbon footprint, sustainable forestry practices, technology advancements, social positive impact, and global sustainability goals, benefit water consumption, local sourcing of materials, well-being of current and future generations, circular economy, help resource generation, energy efficiency, and waste reduction. So all these construction material, I will just give you the brief. How can we use by replacing the natural aggregates, and they are more sustainable and they can make a more greener earth and carbon sink technology. If we talk about the recycled concrete, you see the line diagram chart. How can we make a transport by using primary crushing, then screening, separating, reuse, and demolition. So from demolition to transport, from primary crushing, screening, separation, and reuse. So this is the you can the circular system. So recycled concrete is a pivotal eco-friendly construction material derived from crushed concrete debris. It mitigates the environmental impact associated with traditional concrete production by repurposing existing materials. So when you are talking about the recycled aggregates or recycled concrete or the crushed fine from concrete, they can be easily utilized both as a fine and coarse aggregate. You can make a better concrete. You can reduce the CO2. So recycling process maintains fundamental properties such as compressive strength, durability, offering a sustainable alternative without compromising structural integrity. Recycled concrete finds extensive use in various construction applications, serving as a best material for road construction, embankments, and foundations. Its versatility extends to structural components like beams, columns, showcasing its adaptive to increasing resilient and environment responsible building. So overall, if you see the overall market, in 24 it was 2.67 USD billion and expected to grow from 2.84 USD billion in 25 to 5.06 billion by 2034. And annual, if you see the CAGR is around 6.6% from 25 to 2034. So more the construction demolition waste available, more chances of growth and more chances of research on this particular type of concrete aggregate, be it is a fine or coarse. Then recycled paper, you can see how can you make a paper recycling process from transportation to sorting, then pulping, de-inking, drying, then reorganization and new products from waste collection. So start from waste collection, you can take a new product, and this recycled paper have an innovative eco-friendly construction material crafted from post-consumer waste paper, often mixed with non-petroleum based resin and pigment. The paper fibers are compressed and sealed with the resin to create a durable and solid surface. Recycling process diverts significant amount of paper from landfills, but it also results in lightweight and heat-resistant material suitable for various applications. So you can use it as a lightweight and heat-resistant material also, apart from your construction purposes. Recycled paper countertops exhibit excellent tensile strength, resistant to scratches, making them an ideal choice for kitchen and bathroom surfaces. Recycled paper countertops reduce resource consumption, promote a circular economy in the construction industry. So overall, if you see the market, it is around 32,558 million in 21. Now in 28 it will be 42,395 USD, and it is estimated to grow at a CAGR of 3.8% in 7 years. Then this is another construction eco-friendly construction material, reclaimed wood. You can see how the from whatever the waste log available, how can we reclaim the timber and it can be utilized. So it is another broad area of research. Source from salvage timber, reclaimed wood promotes sustainability by repurposing materials that would otherwise go to waste. It has an inherent strength, durability, and character, make it a versatile choice for a myriad of construction projects. So whatever the reclaimed timber, they have the same almost equal strength and durability. It terms is structural application. Reclaimed wood excel in creating sturdy beams, columns, and framing elements. If you see in India, the northeast, we have the so many availability of timbers, and in some parts of in south also, so that can be utilized as a construction material for beam and other structural members. Reclaimed wood supports builders and designers to contribute to the circular economy, diminishing waste and affirming a commitment to responsible construction practices with prioritizing ecological preservation. And global reclaimed lumber is also named as a wood. The market reach of USD 62.2 billion in 24, and it's set to grow of 3.89 CAGR from 25 to 33, which will be reaching 88 billion USD by 2033. So you can see what is the scope of this reclaimed wood. Then photovoltaic glass is another. You can see from the this circular diagram how we can take this all the solar panels or all the different photovoltaic glasses. How can we recover it and how can we utilize it from if end of lifespan, make a separation, then lead and silver removal. Sorry, lead removal and silver recovery, then wafer recovery, then wafers recycling and cells manufacturing. So again, you can see the lead-free panels are available after the recycling process. So photovoltaic glass is typically composed of layers of tempered glass. These panels are designed to harness solar energy while maintaining transparency. So there is another challenge. How can we make a calcination of the solar panels, or by using this solar panel again after 10 to 15 years of use? The construction involves embedding thin film photovoltaic cells within the glass layers, allowing for flexibility and adaptivity to various architectural applications. Photovoltaic glass not only serves as a building envelope but also generates clean and renewable energy and widely used in windows, facades, and skylights. It seamlessly integrates sustainable energy production into the structure. Photovoltaic glass exemplifies the synergy between energy efficiency and architectural design, contributing to the transition towards greener and more sustainable construction practices. If you see the US market, 7.8 billion USD of solar PV glass market from 23. Now it will in 28, in 5 years it will be around more than 4 times, 27.3 billion, with a CAGR of 28.4%. So there is enough scope of use of these photovoltaic glasses. Then cork is nothing but eco-friendly construction material which having the value of exceptional properties and diverse application. You know the bark of oak trees, it is taken from that. The process is environmentally benign, allowing trees to regenerate and continue absorbing carbon dioxide. So you know the this oak tree having the capability of reducing the carbon sink or carbon sink technology or carbon dioxide reduction. Cork has a notable property of natural resilience, offering a compressible and lasting material that recovers well from compression. So this you can see from the diagram how these cork sheets and cork with the help of this recycling process, we can again make a from waste to again a natural cork. And cork is impermeable to liquids and gases, making it an ideal flooring material particular to areas prone to moisture. So you can use it in a where the moisture is more, the cork is can be used as a renewable and versatile resource. Cork embodies sustainability in construction, offering a viable alternative that not only enhances the energy efficient building but also support biodiversity and conservation. The global cork material market size is, if we see the value, around $5.2 billion in 22, and it is expected to reach around $8.6 billion by 2031 with a CAGR of 5.8%. This is recycled glass. All you know that there is another challenge: how much waste collection we are taking from transport, sorting, crushing, melting, recognition, new product. So this it is sustainable and versatile construction material. Ultimately, the main aim is to use it how which application. So ultimately, in construction purposes, you can use in the various aspects or application. Be it is a terrazzo flooring, countertops, decorative elements, showcasing adaptability in both residential and commercial spaces. So this recycled glass can be used in the form of aggregate in concrete also to improve the structure strength and durability. This glass recycle market, if you talk about, it is $3.2 billion in 23. Now it will be increased by 5.1 billion by 2030. Hempcrete. Hempcrete is also another eco-friendly construction material. Any questions? Okay, should I continue? Okay, so eco-friendly construction material has gained prominence from the unique blend of sustainability, insulation properties, and versatile application composed of inner woody fibers of hemp plant. So there is a hemp plant lime in water that is made in another hempcrete. This is the carbon negative material and can be utilized for roofing and walling. So you can say the person is using as a walling. You can use as a roofing also. The density is very low. It can be used as an infill material, creating well-insulated walls with a breathable quality that prevents mold growth. Somebody is saying something or I am audible to all of you? Anybody?
Yes, sir.
Yes, sir, audible. Yes, sir.
Okay. So the hempcrete is the new research area you can do. It is able to sequester carbon dioxide during its curing process. And hempcrete exemplifies the harmonious integration of renewable resources, energy efficiency, environmental responsibility, fostering a paradigm shift towards sustainable and resilient built environment. So you can use this extracting from hemp plant available in the various northeast area or some different parts of India. And by using the lime and water, you can make these type of hemp blocks, and they are having the longer lives and strong, lightweight, and breathable membrane. So overall global hemp market from is 24.8 billion in 24. It can be projected to grow by around 5% CAGR from 25 to 30. So this is a recycled plastic. All you know, we have to now the single-use plastic is normally banned, and now it is banned by the government. So we can use the recycled plastic in different application. How can we make a collection of waste, then sorting out, shredding it out, and washing and making a proper fabrication. So recycled plastic exhibit the high durability, moisture resistance, and immunity to insects, making suitable for outdoor applications. And recycled plastic lumber, for instance, can replace traditional wood in decking, fencing, and landscaping, offering a low maintenance and long-lasting alternative. This contribute to wall construction, providing insulation, weather resistance, real-time application extend to structural element such as piling, or you know the piling work, which are used in marine construction due to their resistance to water degradation. Recycled plastic into construction project contribute to circular economy principle by mitigating the environmental impact of plastic waste and create durable, eco-friendly structure and align with the emphasis on sustainability of construction industry. So overall, we talk about the recycled plastic market is around 5 billion USD in 24, and it may be reached for 6.6 billion by 2029. This is the algae based. So now the new research is coming on the microalgae or algae based building materials. So these algae based building are innovative and sustainable approach to construction, leveraging the natural properties of algae to create eco-friendly solutions. So you see the person who are handling this algae based bricks, algae based structural elements. This material often involve incorporating algae into concrete or other matrices. So algae having this natural calcium magnesium ions, you can easily absorb the CO2. It can be by using the carbon capture and lowering the carbon footprint. You can make these solid bricks or solid other elements, the blocks also. And algae's rapid growth and ability to thrive in diverse environment contribute to eco-friendly nature. It can enhance the structural strength of traditional construction component by introducing the biodegradability and potential improvements in indoor air quality. Its application range from algae-infused concrete for building structure to panels and coatings, which harness capabilities for energy efficiency. This approach aligns with the broader goals of creating sustainable, regenerative building materials that mitigate environmental impact and promising avenue for eco-conscious construction practices. So if you see about the global algae market, which is especially in the application construction, it is projected to grow an estimate of USD 7.35 billion by 2032 from USD 4.23. Currently, it is 4.23, and it will increase within the next 7-8 years around 7.35 billion. Now, this is the insulated concrete forms. These are also another sustainable construction material. These insulated consist of interlocking lightweight forms made of materials like expanded polystyrene. Polystyrene is having the inner materials. You see the anatomy of ICF walls. So there is a reinforced concrete and there is a exterior stucco finish, acrylic stucco base coat, and you can see the how can we make a reinforcement as a reinforcement element. And this EPS, you see the bottom the picture, the expanded polystyrene foam insulation has been inserted, and they can be used in a walling. They have the capability of thermal performance, better thermal performance, reducing energy consumption, and can be used in both residential and commercial applications with the balance of structure strength. Speedy construction, because due to lightweight, you can make a speedy construction by reducing the waste, and more sustainable built environment as a eco-friendly construction material. So global insulated concrete forms market is valued around 1.2 USD in 23. It may be reached around 2.1 billion by 2032. Another one is the salvage bricks. The bricks which you are using, they can be used again as a sustainable eco-friendly material taken from the deconstructed buildings or some demolished construction sites. They are reused, significantly reduce the demand for new clay extraction and energy intensive brick manufacturing process. Application residential innovation to commercial development, offering a unique blend of historic authenticity and environmental responsibility. You know, we cannot change the historic buildings aesthetic value. So you can use these salvage bricks, and some other architectural monuments building, you can use these salvage bricks to maintain their integrity and their aesthetic value. They can be employed for exterior facades, pathways, accent wall, and landscape projects, emphasizing their versatility in various construction contexts, help in waste reduction, conservation of resources, and the promotion of circular economy principle. So if you see the global brick market of salvage bricks or reclaimed bricks, it is around 1684 USD in 23, and it is projected to reach around 2357 billion by 2034. And this is a rice husk particle board. Rice husk is normally available, and you know that is a good agriculture waste, can be utilized as a cement binder also, having the good pozzolanic value. So these boards is a eco-friendly construction material for replacing the traditional wood burst boards. It is a byproduct of rice milling and a binder. This construction material manufactured through a process of high pressure and heat compression. So you can see the diagram, what the actual picture of this rice husk with a in between the wood strands, and you can see how through the hot processing this rice husk is obtained. So ultimate aim is to make the construction purposes for lightweight design, strength and versatility. Rice husk particle board find application in various construction elements including furniture, cabinetry and interior paneling, and is promoting sustainable forestry practice and mitigates the environmental impact of rice husk disposal. Rice husk particle boards supports circular economy principles, repurposing agriculture byproducts into durable and functional construction materials suitable for diverse building application. So if we talk about the overall market global, it is around 2.5 billion in 2020, and it may be increased 3.5 billion ton in this year. These are the cast earth blocks. They are another good eco-friendly construction material comprising of mixture of earth, you know, the earth materials, stabilizer, and sometimes fiber. So these cars are having the natural thermal mass, can include the natural thermal mass, regulates indoor temperature and breathability, promoting healthy indoor air quality. These blocks are often produced on site, minimizing transportation related environmental impacts. Cast earth block find application both load bearing and non-load bearing. So you can use this type of cast earth blocks by using the natural earth stabilizer and some fibers. You can utilize in the indoor as well as outdoor application for both load bearing and non-load bearing walls for sustainable alternative to traditional bricks. The material's adaptability and ease of production make it suitable for various construction projects, particularly in regions where the raw material are readily available. It enhances sustainable construction practices, utilizing local resources and reducing the ecological footprint. So overall, global concrete, this cast earth blocks market or compressed earth blocks market is around 350 USD billion in 2021, and it may be reached around 369 or 370. Sorry, 369 into 22. It may be reached around 566 billion by 2029. And you know, the aluminum is also whatever the recycled aluminum we can be extracted from the this aluminum industry. So you can see this is also having the sustainability part, is a eco-friendly material. It having the ability of corrosion resistance, strength and lightweight nature, make it an ideal choice for construction application. Okay, it can be used as a roofing, facades, structural components, window frames, showcasing its versatility in both residential and commercial projects. And it supports green building initiative aligning by environmental standards and certification. It helps in circular economy, promoting resource conservation and minimizing the environmental impacts associated with traditional aluminum production process. And if you see the global recycled energy market, it is around $49.1 billion in 22. It may be reached by 101.7 billion by 2032. This is the gypsum board. All you know, the gypsum board is also having the recycled content. So this gypsum board can be also used for the roofing purpose. So they having the properties of board include fire resistance, sound insulation, and ease of installation. Utilizing this gypsum board reduce the demand for virgin gypsum, mining, conservation of natural resources, and decreasing environmental impact. So this gypsum board perform compared to conventional gypsum board, meeting industry standards and certification. Its application may be for interior wall and ceilings, surfaces to partition also, and enclosures. The material is versatile, accommodating various finishes and bands. Recycled content gypsum board supports sustainable construction practices, promoting resource efficiency and contributing to circular economy. So global gypsum market is in 24 it was around 31.7 billion. It may be reached by 2033 47.9 billion. And now we talk about some sustainable construction journey in this particular decade. If you see from 2020 onwards, so some technology innovation has been done in material processing. All you know, the new concept is 3D printing. All you are aware about the 3D printing, which emphasizing the precision and waste reduction, and novel complexes designs that minimize material uses. Then automated or robotic framework fabrication. It focuses on speed and efficiency, reduces labor cost, and enhances precise manufacturing. So basically, this all are the software-aided tools, the run from the programming, and then they can easily make a fabrications and make a faster construction. The BIM, the building information modeling, is another new concept, especially in construction design. It having the good planning, reduce resources use, and improve coordination accuracy in material application. So you see the 3D printing, how it can be make a you can say the utilization of the proper materials in a proper manner, optimizing the materials, and layer by layer construction. This is also known as additive manufacturing. The technique has precision, means significant reduction in waste compared to traditional construction method. So you can utilize the local materials available also. You can utilize it in any form of construction, be it is a commercial building or residential structure. It having the complex organic geometrical structure that optimize material distribution, structure integrity, often impossible with conventional construction techniques. So in conventional construction technique, it is very difficult, all the complex geometry, all the different optimization part or structure integrity, which it can be done by the 3D printing. So this is not only enhance design freedom, but also improve the material efficiency of building. So we have also the one of the indigenous 3D printing in our institute. So we are making this 1 meter by 1 meter by printer. By using this, we are optimizing the different local available materials, binders, so that we can give the industry a suitable mixes and developing the codal provision also. This is the automated and robotic fabrication. You know, how can we make a adequate construction through the use of the software tools? These robotic fraction have developed to further increase efficiency, precision in construction processes. Robots can be programmed to perform repetitive high precision tasks as a bricklaying, welding, and cutting. So you can see by the picture, you can utilize it not only in the load bearing construction, but also in the RCC structure also. Greater speed and accuracy is also obtained, and skill is required, but that can be imparted through the training. And automated system reduce the time and labor cost associated with building construction, minimize the human error, leading to safer and more reliable construction practices. Additionally, this robotic fabrication support the implementation of advanced materials. So basically, by using the software tools, programming, you can use the local available material, the binders, and make a high performance composite by handling them in a way to optimize the property during the construction process. So property can also be checked during the construction process and post construction practices. This is a prefab or pre-engineering building that you know now the target is to make a faster construction, especially the important industrial structure or warehouses. So pre-engineered building allow for more storage stacking than the conventional concept such as concrete and site fabricated structure steel. PEB permits the use of optimized column free space to suit racking arrangements and internal logistic requirement. And these having totally shop fabricated require bolting of components to get to the same as a site connected to previously completed foundation and substructure. So you can connect it from a foundation to the top level, and they are faster construction, more reliable construction, more efficiency. PB features a structural steel framework of primary and secondary members, having the rigid frames, beams, purlins, and girds, trusses, and columns, on which cladding and roofing components are attached. Building is intended for commercial, industrial, and institutional occupancies, as I told you, and make economic and speedily construction. This is the BIM, all you know, the building information modeling. The main purpose of BIM is to make all the stakeholders, be it is architect, builders, or consultant, they are on the same wavelength. They can get an idea of whatever is happening in the building, each elements, how it is constructed, what are the processes the builder is doing. So they are on the same path and allow the virtual design management of building throughout their life cycle. BIM models help to plan and stimulate the construction process before physical work begins, ensuring the material usage is optimized and potential issues are identified early. So you can make a proper planning as earlier before the construction. This integration not only streamlines the construction process but also enables a more sustainable approach by minimizing waste and improving overall building performance. So another new technology is coming, the digital twin. So it is the upgradation of BIM. The physical twin, you can see the photographs, it is a BIM. It can be used for the design and construction, but digital twin can make a assessment of the performance of the building in terms of operations. And you can see the how can we data collect from the actual asset or actual building, and we can make a similar replica of digital twin by whatever the lapses has been done in the physical twin or actual existing structure. We can minimize the lapses in the digital twin. So digital meaning the exact digital replica of construction project or set, a building or group of buildings, a bridge or highway or city block or even an entire city. So you can make a smart city construction through the digital twin by replica of this all the different blocks. Digital twin construction can called as a data twins, virtual models, or even next generation as a built drawing. So you need not to be having the additional drawings. You can make a proper digital twin to the earlier existing physical twin or existing building. Digital twins are created by gathering and combining real world information about the building or structure using technology, three-dimensional laser scanners, drones, sensors, cameras, and IoT based devices. Digital twins supported by IoT or artificial intelligence is able to learn from multiple sources and automatically update to reflect adjustment made to its real world counterparts. Digital twins delivers information on the object's properties, states information. Basically, the whatever the three-dimensional view you are doing in physical twin, you can get an idea of the objects, states information, and physical orientation, shape, position, gesture, motion, as well as inside other status, interaction, and updates such as stress loads due to traffic or wind or leaking pipes. Digital twin technology add a new level of sophistication to BIM models so that stakeholder can visualize the real-time status, working condition, and position of physical assets. So basically, all the static things which are you having the physical twin, you can convert into dynamic or real-time information. So this is overall about this, my lecture. So I hope you have enjoyed. So now you can ask any query from your side. Thank you. Thank you very much. Okay, so you can ask any questions. So I think I go to chat box also. There is no question.
Sir, here are the few questions. First question is from what about the Rick's hard board resistant to termite? This question has been asked from Dr. Bharat Bhushan Jindal.
Just a minute. Can you repeat the question?
What about the Rick's hard board resistance to termite?
What are the?
What about the Rick's Hus board resistant to termite?
Termite.
Yes, sir.
For like termite proof structure you are talking.
Sir, it is asked from Dr. Bharat Bhushan Jindal. It is in the chat box. You can see.
Okay, just a minute. There is a one question. How does the use of steel slag contribute to reducing the carbon footprint, cement and concrete production? Okay, so you know, basically all the steel slag or the different slags, they having the this extraction of calcium and magnesium ions. Especially if we talk about the primary steel making or secondary steel making, they having the extraction of calcium and magnesium ion through the either through the solvent techniques or either through the gas techniques. So by extracting the calcium and magnesium ion, you can incorporate the CO2, which will be converted into CaCO3, and you can get a more solid aggregates compared to the original one. So this steel slag are already is being used, but the unattended LD slag or some other different type of slag, which have the impurities, they can be utilized by inserting the CO2 and making a viable aggregates. Okay, the second question is, what are the main construction materials or products that can be made using steel slag? So basically, the steel slag can be utilized as a coarse aggregate, or it can be utilized, the steel slag fines can be utilized in a fine aggregates, or you can make it is a valuable product like tiles or blocks. So I think these two questions by using by Revant, P. Revant. Then another question, Akash Parva Panda. We have found an alternative limestone as it is a non-renewable material. Can we rely on the coming years? Yes, we have already, I have shown you my slides. We have the alternatives of limestone, and you can see, because we have to minimum clinker percentage we have to maintain around 35 to 40%. Today we have reached around 45%, but we will go to the 35%, 30%. But all the pozonic binders or different industrial waste, they can be utilized, and in the next coming years of 20 or 30 years or 40 years, you will get the sustainable binders basis cements by reducing the clinker content. Okay, another one is the question is, any bio-based materials serve to reduce CO2 emission? Yes, I have already shown you the bio-based materials in the list of the several materials, from agriculture waste to the different cow dung or different this agriculture waste. They can be utilized to reduce the CO2 emission because they are having the pozonic properties, and all these pozonic property they can reduce the CO2 emission. That's why we have targeted so many cements by using the pozonic materials. What are the, another was Jobil Varghese, what are the sustainable materials for coastal application? All you can use this slag cement. You can use the Portland slag cement. You can use the slag cement and fly ash combination also. The composite cement you can use for the coastal applications. Okay, any other questions? I think okay. Another one is,
Sir,
yeah.
hmm.
I think Mr. P. Revant has given in chat box, can steel slag based brick blocks can be safely used? Yes. Because steel slag having the you can say good property in terms of compression and tensile. So you can use it in a safely in construction, and they are more fire resistant to conventional clay or concrete brick. Because you see, if you talk about the slag aggregate, because most of the Portland slag cement or Portland this ternary blend using with the fly ash, they are now more in use in construction, being the more aluminum silicates of composition in the cement, and they are lesser heat of hydration, so less cracking. So you can utilize in as a fire resistance also, because in fire resistance there is more chances of cracking or some others. You can say fissures or some thinner cracks that can be avoided by the use of this. Any other questions? I think there is no other questions in there.
Sir, one question from my side, Dr. Nakul Gupta this side.
Yeah.
As few days back, we have seen there is a launching of calcined clay based cement by JK Cement.
Yeah.
So means as we have fly ash based PPC, we have slag cement. So how this thing is different from PPC?
Okay. Basically, if you go with the different types of binder,
Or how it may help when PPC or slag based? Yes, sir.
actually, if you if you are using the PPC, there is a demarcation of percentage of fly ash in the OPC with fly ash content. But when you are using, like in OPC, the directly you are extracting the fly ash from thermal power plant, so you can get an idea of the blend percentage, fineness, or all the other specific gravities parameter. You can optimize this on your site itself, and you can also increase the fly ash up to the more than the limit of 35% as recommended by BIS, up to 40 or 50%, because most of the roads of the cement plants, they have used the high volume fly ash roads up to 50% or 60%, and in the foreign countries they are using 70 to 80%. Only we have to see the adulteration part, the fineness part, or the specific gravity of fineness. If it is okay, or if they are having the good pozonic value, then they can be utilized up to 50, 60 or 70%. And they can be more they can reduce the CO2 emissions compared to OPC cement, and lesser heat of hydration also. Okay, I think there are two other questions. What are the tests to perform and check CO2 emission? It's a simple. You can if you are using in concrete or mechanical and physical property, you can check it out. And first, it is from through conventional concrete, and then after using these different types of alternative aggregates, you just compare what are the physical properties of the original one and the recycled one. So it is very easy in the laboratory. There are so many tests you can use. The in physical, the understanding the aggregate testing, then the cement testing in conventional method, and by replacing these all the different binders or different aggregates. And then you can do the mechanical testing also, the compression CTM machine, then tensile testing, so that you can get a better idea what is happening, whether it is up to the level of my conventional concrete. So then geopolymer concrete is emerging as an effective alternative of traditional Portland cement based binder. However, its cost is higher. Can we minimize its cost by introducing any other material or through any other means? Yes, because geopolymer is totally a synthesization of the fly ash or slag. So they are the very less they are less costly than our limestone. So you can use it as a binder. However, only thing is you have to make the Nash or cast the sodium or potassium activators. So now all the companies are now giving the less costlier material. So by synthesizing these, you can make a proper geopolymer concrete or geopolymer cement. So in the next, you can see the code has already arrived. You can see more and more geopolymer concrete will be used by the industry. Then last one is replacement of cement with geopolymer technique is suitable for coastal. Yes, you can use it in any applications because geopolymer having the fly ash and slag, so that is a versatile material for resisting the corrosion as well as carbonation and sulfate also. So I think any other question you can want to ask, so we can go ahead. So I think there is no other question in the chat box. So directly you can ask any question if anything has been left.
Sir, there is one more question in the chat box.
Okay, just a minute. Okay. Somebody has asked P. Revanth, what strategy or key points can help convince clients or builders to adopt shear wall technology instead of traditional brick wall construction in residential high rise? This is not related to this, but again, the shear wall by replacing brick wall, it is definitely every consultants or every clients know, because if you see the brick wall construction, they have the poor resistance in seismic point of view, in the wind point of view, or in the point of other dead loads or live load. So shear wall can be most of the multi-story buildings or the industrial building, they are using the shear wall. However, this G+2 building or G+3 buildings, they are not using, but that can be promoted by discussing with them, by using just giving them idea of the testing part of the shear walls technology and comparison to brick wall. So you can see the shear wall is having the in the all the frame structure, they are giving the better results in terms of moments, the shear forces. But if you see the brick wall, they collapse during the high seismic forces or seismic you can say natural, if any dead load is more, if you are planning for another floor, then there is a chances that they cannot pass the load from top to bottom. So this is the technology you can give the idea through your test data or strengthening data. Now, last one is what alternatives retailers can effectively replace traditional Portland cement, which has been used for over a century. Already I have discussed all the positioning material. How effective carbon fiber wrapping? Carbon fiber wrapping is improving the confinement strength as well as shear capacity, especially in the structures, but that can be used after proper analysis through the non-destructive technique method. So these wrappings in the form of carbon, glass fiber or aramid fibers, they can enhance the strength in terms of shear capacity and flexure capacity also. Okay, and then also to like carbon capture emission to produce carbon based Yes, you can use the substitute this by using the alternative techniques, structure strengthening techniques, by using the shear walls, bracings, then jacketing. All these are the strengthening techniques. Okay. What are the main practical difficulties industries encounter when transitioning to low carbon cement production or incorporating alternative raw materials? The technical difficulties, the awareness. Awareness is not there. If they will come in the various conferences or forums. So all the builders will definitely come to understand what is the how can we utilize the low carbon cement better way? How can we reduce the heat of hydrations? How can we reduce the cracks? So that this all these codal has already come. So sooner and gradually in 456 all thing will come. The structural concrete, the another name will come in the code. So they are coming with the different alternative materials. So everybody is now they have the mandate to use this type of blended cement or quaternary or ternary blends also. So I think any question left? Costing aspect. Which costing aspect? Somebody has asked. May I know the costing aspects? It is in terms of cement. Because only the question is, may I know the costing aspect? Somebody has asked. But the question is incomplete. Your aspect, you are talking about the ordinary Portland cement versus the PPC or PSC cement or some other aspects?
Hello.
Yes. Yeah, tell me. The question, the name is not written. Who is asking the costing aspects? But actually, name is not written. Somebody has asked the alternative materials. What alternative materials you are asking? Already I have shown you the different alternative materials. Okay, actually question is incomplete, so I cannot answer at this junction. If any question is proper, then I can give the reply. Okay, some more messages are there. What about the rice export resistance to termite? Yes, this questions earlier you asked, Bharat Bhushan. Rice has board resistance to termite. Definitely these having the good affinity, good property of the like regarding the termite proof, because these boards having the you can see the this board can be utilized in the walling as well as in roofing also. So these board having the they can be making the like some painted also outside this, so making a proper termite proof also. But these boards having the proper insulation as well as some reinforcement part, so it is not easy to reach the termite. However, for better production, you can make a painting arrangement or one or two layers so that this is intact rices board can be prepared. Okay, now I think every question has been attempted.
Hello,
Any
sir.
questions? Yes.
Sir, my questions is what are the main advantage and structural features of pre-engineered or prefabricated building compared to conventional construction methods? Sir, I type my answer in chat box also.
Okay, so I think I think this slide is open. You can see this is basically the faster construction, the use of the structure steel members, the use of the formwork. So they having the release of the spaces, the free spaces can be you can utilize. You can minimize the cost by replica of this particular type of structure from one place to another. And secondly, the efficiency in the form of design is improved. As you already know, this is a structure steel framework or the girders or the beams or the purlins. They are not only reducing the spaces of the your overall building, and they can be utilized on all purposes, be it is a cladding, be it is a roofing, be it is any structural member. From conventional concrete, it is very difficult to understand the performance part. They are, you can see by in the design aspect, they are more better. You can utilize it in, better efficiency can be taken, and most important, the operation can be easily you can check the performance comparison to conventional building, and you can go more vertical heights as compared to conventional building. So these are some special aspects for both commercial, industrial, and institutional buildings. And the main aim is to minimize the operation cost, which it can be minimized compared to conventional cost, conventional construction, or overall life cycle cost can also be reduced.
Thank you, sir.
Okay, I think last one is from your experience, what are the main practical difficulty industries in when transition? Okay, I already have discussed. Because the industry is have to be like in transition phase. They are now using the binders, so code are coming. They are now using. So it will take another 5 or 10 years to replace the OPC cement with the PPC or PSC or composite cement, because results are promising. So performance part is also durability part has already covered. So many results has been given to BIS or some other industries or some other government agencies. They are now using this different types of uh, low carbon cement. So now any questions is left? Otherwise, we can close this.
Yes, sir. We can close. Thank you, Dr. Mundra, sir, for the deep and essential focus on the material side of sustainability. We will be concluding the next session in 7:30. Participant, please wait for the few minutes. We will start the next session in 5 minutes.
Okay, thank you everyone. Thank you, Ajit. Now
Thank
I just close my lecture. Or anything you want to discuss, so you can send through your faculties. We can like answer your questions also in the future.
Sure, sure.
Yeah, yeah. Who is there? Any question?
Sir, there are no questions.
Okay.
Thank you for your guidance.
Okay, okay. Thank you. Thank you very much. Thank you, everyone.
We now move on to our second session of the evening, session 4, from 7:30 p.m. to 9 p.m., where we will examine sustainable method of construction. The topic is sustainability in precast construction technique in MRTS, Mass Liquid Transit System. This session connects two major themes. First is rapid urbanization, second is sustainable methods, especially within our critical public utility like the metro rail. It is my distinct pleasure to introduce an expert who has been integral to the growth and governance of the world's third largest metro network, Mr. Anil Patel. Mr. Patel is currently serving as a professor of civil engineering at DMRC Academy, the premier training institute of Delhi Metro Rail Corporation. His career demonstrates a unique blend of execution, governance, and academic training. He began his career in 2012 at DMRC, where he was involved in the execution of the critical infrastructure, including an underground tunnel on the Pink Line. He served as a senior vigilance officer from 2016 to 2020, focusing on upholding integrity and enhancing risk mitigation and in infrastructure management. Mr. Patel holds a postgraduate diploma in metro technology and management from IIT Delhi. His exemplary performance was recognized with the Managing Director's Award in 2025, the highest honor in DMRC. Mr. Patel will share his practical expertise on how the precast technique, a method ideal for speed, can be optimized for efficiency and sustainability within complex urban transport systems. We now open the platform for this crucial discussion. Please save your questions on precast methodologies, life cycle assessment, and MRTS sustainability for the question and answer segments. I invite Mr. Anil Patel to take the virtual stage for the session 4. Sir, please welcome.
Hello, am I
Yes, sir.
audible?
Yes, sir, you are audible.
At the outset, I must thank to Shri Ajit Singh Baghel for this very kind and I would say generous words for me. So I could see more than 100 people are connected, around 100 people are connected to this forum from various part of the country. So
Yes, sir.
it's my privilege to be here. And yes, as rightly said by Mr. Ajit, topic given to me is sustainability in precast construction techniques, particularly in MRTS, that is Mass Rapid Transit System. In very common language, we call it metros. The metro word is derived from metropolitan terminology, basically. And so, should I start if I'm audible loud and clear?
Yes, sir, you are audible. You can start.
Yeah, so I'm just uploading and sharing my presentation first. So let me know if you all can see it from your devices. I hope my screen is visible to you all. Shajit, could you please confirm?
Visible, yes, sir, it is visible.
So yeah, so
sir, can you put this presentation in PPT?
Yeah. Just wait. I'm doing it. So
yes.
Hope now full screen is visible to all of you.
Yes, sir. Yes, sir.
And I think it would be better if I turn off my camera, otherwise it may consume my data. So, okay. So yeah, as I mentioned, topic is in front of you all. So this 1.5 hour, I will be basically talking about all these terminologies, sustainability, precast, and MRTS, what we are doing in particularly in metro sector. When I say metro sector, in particularly in our country, DMRC, Delhi Metro is leading in that sector. And whatsoever construction techniques, type of structures, and methodologies, be it green techniques like green ratings, GRIHA, and IGBC, or any kind of sustainable measures you all are, I would say, witnessing or observing across the metro sector, that is being driven directly through this organization, that is Delhi Metro. So more or less, as on date, I just to give you a brief overview of the metro sector in the country. As on date, 33 metro organizations are currently in place, out of which 15 metros are in operational condition, means you can travel into those metro system, and the rest are under construction. In terms of world status, So we are having a route network of around, as a country, we are having a route network of around 1,050 kilometers precisely, and we are third largest metro system. Obviously, on top, China is there, and then second is USA. Recently, as a country, we have surpassed Japan in that in terms of route length of the metro system, particularly. Very soon, we are going to surpass USA also. We will be the second then. So that was the global perspective of this metro sector, and I'll basically discuss three major aspects of the metro system in terms of sustainability and precast. So more broadly, if you see, metro corridors are either running above the ground, that is called elevated section, or below the ground, just below the ground, that is to which we call it as the underground section or underground corridor. It's very rare you will find any metro system running on the ground or at the grade, we call it as, because our metro systems are basically designed to cater urban setup, not to other intercity or interstate connectivity. So in dense urban sprawl, it's very tough to find out the ground or surface area to lay the track and run the train of metro services throughout its life cycle. So till here, is there any issue? Am I audible to all of you?
Yes, sir. Slides are not moving.
No, I'm not actually moving the slides yet. That was some kickstart talk I was basically giving. I'll be discussing the topics at slides very soon. Just give me a couple of minutes more. So that was the basically perspective of this entire perspective of this metro system. In nutshell, it is called MRTS, Mass Rapid Transit System. We all know why we have adopted MRTS system over other mode of transport like bus, or that is basically surface transport system, or even skyways. You might have seen ropeways and cable cars. Even light transit rail systems are also options. But in metropolitan cities like Delhi, Kolkata, Mumbai, Chennai, and so on, mass rapid transit system is basically a synonym to metro system, not other skyways or LRT or other systems. Because India is the most populous country in the world, and so our urban nodes are also very populous. Urban nodes means Delhi, Mumbai, and likewise. As on date, we are catering as a metro system in the Delhi around 80 million, 8 million passenger journey every day. So let me start with the quick glimpse of this entire organization. So we are basically a registered company, or I would say PSU kind of organization that was registered in way back in 1995 on 3rd May under the Company Act. It has equal participation from Government of India as well as Government of Delhi. It's a special purpose vehicle. And as on date, we have basically created a huge network of around 400 kilometers, out of which there are 289 stations, if you include Noida line and Rapid Metro Gurgaon. And we are actually running our trains with a very niche technology or very latest technology, you would say, across the globe, that is called unattended train operation. It's a fourth level of, I would say, fourth grade of automation. The highest grade of automation is the fourth, which is being used in airlines. That is unattended train operation, or you can say unmanned train operation. So we are using that technology in especially pink and magenta line. And our trains are basically using this technology that is called communication-based train control system, means trains talks to each other as well as with the operation control center through the system. So that is how this UTO system is basically, UTO feature is basically ensured by using CBTC technology. As on date, we are also in the process of indigenizing this technology. Till now, this technology is basically imported from outside overseas. I hope you all are able to see the slides moving.
Yes, sir.
Okay. So as on date, as I mentioned, we are serving more than 8 million passenger journey with a fleet of around 350 plus train sets we are having currently. So DMRC is known for this last point that is called carbon credits. It is the first metro rail system in the world which got carbon credits by UN, and that is because of this reduction in the greenhouse gas emission through regenerative braking system. So this metro system is using this regenerative braking system. That is why it is known to all. And obviously the practices, construction practices, and the fast construction practices that made this organization loud in across the its peers and every other sectors. And we are also generating solar power from our own rooftop installed solar system that is more than 50 megawatt power we are generating from our rooftop. That was all about this organization and some technologies which we are using. So let's have a look how this precast construction technology which we have adopted in our construction domain, how it is helping to achieve sustainability, which is the topic of this forum and this session. So we all know construction means conventionally going to the site with all resources. Resources typically means money, manpower, and material, and constructing or making or building the structures as per the design and the drawings. That was a conventional method, but nowadays, in recent, I would say around 15 years, this entire segment of construction or construction industry has evolved like anything because of this new techniques called precast techniques. In that, if you go in big detail, there are subdomains: pre-tensioning, post-tensioning, precast, pre-stressed technology, precast RCC technologies are also there, which we are using in underground sectors, underground structures. So there are lots of structure which we are using as a precast, like girders in elevated corridors, tunnel rings and segments we are using in underground. Even precast slabs are also being used in I would say MRTS sectors. So that is being used in stations. So why this precast had taken so much, I would say, height in its across all other methods? Because in this methodology, the structure which is being produced, it is being produced in a controlled environment like a lab kind of atmosphere, wherein quality of the structure and quality of the processes can be ensured in much more better way rather as compared to the in situ construction or the method which were conventionally being followed. So that is why this has taken much more importance. So if we see in the DMRC, DMRC is also using precast U girder, I girder, T girders, and many other shapes of the RCC girders are also being used. I will share those details in the subsequent slides. In case of underground corridors, in particularly tunnels, which are being constructed by mechanized method, that is called tunnel boring machine or CBM tunnels, there we are using precast RCC tunnel rings. I will show, I will talk about these methods in the subsequent slides. So yes, this precast is basically deriving its uh, uh, quality, I would say, parameters or quality control through a dedicated lab that is called casting yard, where all these precast elements are being actually created, casted, or you can say constructed. And then subsequently it is shifted to the actual site where it is fixed or installed. So let's pick one corridor one by one, and then we'll discuss how precast technologies are being used. And then at the end, I will summarize all these sustainability uh, goals, how we are achieving it. So first, if we discuss underground corridor, so there comes two components in underground corridor. One is the underground station, which is basically nothing, it's a RCC box. If you imagine, RCC box is actually a It's a basically 265 meter length and roughly around 21 meter width and 18-meter depth RCC box, which is constructed just below the ground, and it is having all those systems, machines, equipments, levels like concourse, platform, and track levels where passengers are allowed to board and deboard the metro services. And these stations, these bulky stations, which are constructed immediately below the ground, are connected with each other through a tunnel. Rather, two tunnels. We are using twin tunnel system in metro sectors. So these twin tunnels are connecting each station, and more or less every station is basically constructed at a distance of on an average 1.5 kilometers. That is how it is planned in every city. So we talk about the construction of tunnels using precast segments. So there are three methods actually. One is cut and cover method, which is very conventional method where you go outside and cut the ground and create the tunnel box and then cover it up. It's not a latest or precast method. It's a basically conventional method. The next method, which is EPP or TBM, EPP TBM or mechanized method. This method uses the precast RCC tunnel segments or rings. And last one is NATM method. It's a very dynamic method. You can say we use a dynamic approach to construct a tunnel. It's a new Austrian tunneling method, which is using more of manual approach, using some pneumatic tools and machineries to break the ground. So normally using these three methods, every underground corridor is being constructed, but only in mechanized method, that is TBM method, precast RCC rings are being used. So if we discuss first method, cut and cover, so typically if you see in this sketch, I must highlight. So in first step, what we do? In first step, normally if you see the stations of metro system is constructed normally across the road. So first of all, we have to disturb the ongoing road traffic, and if there is any green area or if there is any green vegetation, we have to scrap all those things, and then we have to dig the ground, excavate the soil, and then place our structure. You see, in step 4, you can see the RCC box is created, and then entire area is restored back, and traffic is again restored back. So in this cut and cover method, there is a huge quantum of excavation and there is a huge disturbance to the existing traffic, existing flora and fauna if it is there. And that's why we can say this method is not much more sustainable, because we are causing lots of damages to the ecosystem and everything, surroundings. So that is why mostly tunnels are being constructed using this mechanized method, that is called tunnel boring method, a tunnel boring machine method. In this method, a dedicated machine is there, which is lowered from a particular location, and then it is allowed to bore the ground horizontally. Simultaneously, while it is moving and boring the ground, simultaneously from the backside, it erects the precast ring. You can see this is rings are shown here typically. These rings are basically RCC rings. These are precasted in a controlled atmosphere in casting yard. Normally in metro system, we are following 5+1 configuration of the rings, means 5 standard segments are there, and one key configuration, one key is there at the top. So that is how every metro system is being using this precast segments in tunnels. So this is the machine. I hope everybody is able to see the photo. This is the machine, jumbo machine, which is being used across all the metros organizations. These are sealed TBMs. The front portion, red portion, is called cutter head, which actually cuts the soil or the rock in front, and the back portion is actually a sealed portion wherein all the equipments, all the components of the machines are installed. Like you see, this is an excavation chamber, and this red portion is actually screw conveyor, which convey back the entire muck or earth which is excavated. And this portion is called segment erector or ring erector, which actually fixes the precast tunnel rings in its position. So these are basically controlled by a remote, which is operated by a person, who is a trained person. So simultaneously, it moves in front direction, and at the rear direction, from the rear side, it erects all the segments. I hope till here you all are with me. So this is how this EPB shield TBM is working. Basically, that is why it is called earth pressure balancing machine. The machine which is cutting the excavation phase has to balance the earth pressure simultaneously with water pressure also. And adding to these two pressures, machine has to exert slightly more pressure so that it can advance in front direction. Otherwise, machine will not able to move. So this is how a launching shaft is created on the ground just to lower the machine in pieces like this. And then or entire assembly of the machine can be lowered in one go, like entire shield can be lowered and the backup gantries can be lowered in the subsequent stages. So this is one more picture where we have installed entire machine in one go, and tunnel boring was started in one go. So normally a machine is having diameter of around 6.5 meter, and total length from front to tail, it is having around 95 to 100 meter length. So it's a big jumbo machine. So this is one of the site in Delhi area where we have used full length machine in one go for the initial drive. This is the one underground station in Old Delhi area. This is a small animation. You can just understand how this is actually working. The cutter rotates and the muck is excavated backside, and from the rear side, tunnel segments are being erected. So these segments are actually precast, and it is saving a lot. It is saving in terms of uh, cost and terms of, I would say, quality also, because the quality control is much more better and effective when we construct these segment in the casting yard. Rather, if you see the conventional method where lining of the tunnel is to be constructed on the site itself, which is very tough, and quality control is very challenging. So precast technique has basically proven for time saving also. So this is some photo. These are some photographs. These are basically some photographs showing the retrieval of the muck from that TBM. The soil which is being excavated, it is being retrieved from the backside. These are the basically muck lorries which are used to retrieve entire soil which is being excavated by the machine. These are another photos of those locomotives. The muck which is retrieved from the ground from the excavation is lifted back to the ground surface area, and from there it is transported to the dumping yard. Normally these soils are being retreated because these are being mixed with some slurry and foam sometimes. So this cannot be directly used for I would say horticulture purpose or other purposes. So it has to be treated, and then it can be used in backfill. Mostly during our previous phase construction, we have used this soil to backfill the train depot area. We have constructed around 13 depots in Delhi where trains are being stable, being maintained in night hours, so that we can operate the train smoothly in daytime. So that area is basically a horizontal area on the ground where permanently land is required. So we have used these muck there. So we have not dumped these muck like anything. We have reused this excavated soil. So these are the basically tunnel segment which is being lowered, a precast tunnel segment which is being lowered to the excavation shaft, and it is being fed to the machine. Ultimately, this machine will lift this segment, and each segment is having a weight of around 3.5 ton to 4 ton. You can see these persons are involved in fixing this segment with the segment erector. Ultimately, this person is using this remote to maneuver the erector so that tunnel precast segment can be placed within the shield to its actual or accurate profile. These are some other photographs where you can see the precast segments is being basically fixed. So precast tunnel segment has being proven like a quick time saving in terms of fast construction of the tunnel. Otherwise, it would have been very nightmare, because when we construct underground tunnels in densely populated urban area, so there is a challenge of subsidence, soil settlement, ground settlement, I must say. And imagine if you are constructing tunnel below the buildings and the roads or bridges. So every every centimeter of the settlement is going to give you very, I would say, nightmare. So manual method of construction like NATM or cut and cover is very challenging, very prone to very, I would say, huge settlements. So this method, this mechanized method is another way of saving those challenges like settlement and everything. So by way of precast techniques, this construction has become very fast, efficient, reliable, safe, and economical as well. Post-construction tunnel profile is being surveyed so that all the geometries and diameter, center of the tunnel remain its design place and its design axis. So these are some of other profiles. These are basically cut and cover tunnels. At some location, we have to do the cut and cover, make tunnel through cut and cover method only, because we have to place some kind of structure like this scissor crossover you can see in the photograph. So here we cannot construct the tunnel using tunnel boring machine. Otherwise, we will have two different tunnels. Then we cannot connect these two tunnels for laying these integrated or scissor tracks. So deliberately, we have to construct this tunnel in this area by cut and cover method only. So these are very few locations in entire network. So job done, smoothly train can be run. So that was about underground corridor and the usage of precast tunnel segment in tunnel, particularly tunnel corridors. As far as the station area is concerned, metros are very metros are not using precast segments or structures in station area, except few locations like one of the overhead track exhaust way is there where we are using precast, I would say, conduits. Otherwise, there is no precast structure in station area. Only tunnels are being tunnels are using precast segments. So I hope I made some sense up till here. So is there any query till here? Anyone please confirm? Hello, am I audible?
Yes, sir, you are audible.
Okay, thank you. So now I'm moving to elevated corridors where metros are using, I would say, precast segments more rampantly as compared to underground corridors. Underground corridors are mostly in underground tunnels, precast segments are being used. But in case of elevated, you will find everywhere precast structures are being used except substructures. Even in substructures also discussions are going on to use precast. So I'm moving on to the next slide. So if we see or compare the growth of the in terms of selection of the type of structure in metro system, these are the basically type of structure which have been adopted till now. If you see the first one, it's a basically pre-stressed concrete box girder. We have also used in DMRC these box girder. These are basically precast post-tension box girders, RCC box girder. Normally, standard span length of around 37 to 38 meter is being adopted in various metro, including DMRC. In this box girder, to erect one span, it takes around 4 to 5 days. And this is the oldest one. This is precast eye girder span system arrangement, wherein 3 eye girders are at precast eye girders are used, and then subsequently slab is laid, and then side from side parapet or curtain wall is basically fixed, and the railing is fixed. This method is also time taking, and in some locations where RCC girders are not viable because of its length and everything, or then we go for steel composite girder or steel girders. At some location we have used, but more or less in phase 4 in the current construction areas, DMRC has now standardized the usage and adoption of precast, pre-tensioned, full span U girders, and that is twin U girder system, which you can see in this photograph here. These are 2 U girders which are fixed or erected over up to span in a single span. So normally nowadays every metro is following this kind of system in case of elevated corridor if they are creating. Up to this column, or we call it as a pier. Up to this pier, this comes under substructure category itself. Up to this pier, entire structure from the ground foundation to the pier cap, and then the pier and pile cap, everything is cast in situ. And from this pier cap till entire superstructure, everything is precasted now. So this is a huge, I would say, adoption of precast techniques in elevated. Normal configuration of the superstructure and substructure is like this. Below every pier of the metro, there are group of piles. Generally, these are 4 in the numbers. One pile is having 1 meter dia, and length is varying depending on the type of strata and geology and geophysical conditions. And then there is a pile cap to integrate all those piles. Normally, diameter of the pier for 16 or 17 ton axle load comes around 1.8 to 2 meter. And pier cap and above structure is precasted now. So first time it was seen in India, this U girder was seen in India in airport metro express line of DMRC. This is a photograph of the same. Pier was constructed on the ground through cast in situ method, but pier cap was precasted like this, and then twin U girders were erected. These U girders were pre-tensioned U girders. These are some of the basically terminologies and nomenclature of the structures. If you see, this is the crash barriers, this is a pier, this is a pier cap, and on the pier cap there are 4 pedestals on which 4 elastomeric bearings are used. On that elastomeric bearings, these twin U girders are basically placed, simply placed. They are not, these U girders are not rigidly connected with the bearings for the seismic consideration. So, and these pier caps are basically precasted already in the casting yards. These are some photographs. Advantage we all know why we have gone for this kind of precast pier caps and U girder, because in case of in situ construction, since metro construction is a linear project like highways and railways, so if we are installing elevated corridor in urban area, so in linear projects, every time we have to shift the material, resources, and everything to its location. And along the linear alignment, it's very challenging to maintain the quality at every location. So it's better to cast all the structure in some of the fixed location, one of the fixed location like casting yard and lab, and transport the section and structures to the location where it is to be fixed. So yes, that is why precast technique is basically used over cast in situ. It is time saving, cost saving as well. It's very simple because every time same mold can be used, and there is a good check on the mold geometry as well. So good aesthetics of the structure, good finish of the structure is also maintained apart from quality and everything. And because of precast over conventional RCC, the section also becomes lighter. More loads can be transferred because of the pre-tensioning and post-tensioning pre-stress technology. So in case of linear projects, there are lots of hindrances to the traffic, existing trees, roads, buildings. So these hindrances and damages to the other structures can be also avoided if cast in situ construction can be replaced with the precast. So that was the basically purpose. If we compare with the previous box girder structures which we have installed in previous lines, this was the arrangement. These are the pier caps. On that, two pedestals were used to be there. And when precast box girder was erected, we have to fix this parapet also. These parapets acts as sound barrier because we are running our metro system in urban areas. We have to take care of the noise and vibrations also. And then on this deck slab of the U girder, we have to install track also to run the trains on that rails. So it was quite bulky. For a standard 37-meter length box girder span, one span was having around 550 metric ton weight. So that was basically one problem. So we thought of using and replacing this box girder with twin U girder. These twin U girder are basically full span 28-meter length, single span U girders. One U girder is having weight of around 65 metric ton, and if we compare entire span as compared to box girder, it's much more lighter. Around one total weight of the one single span having twin U girders is around 170 metric ton. So it's a much more saving in terms of dead weight also. Once dead weight of the superstructure is lowered, so we can go for lighter or shallower foundations also. And there also we can save the concrete and yes, the resources. So this was basically this U girder adoption appeared to be very economical in terms of cost and quantity saving also, apart from time saving. So these are basically one more comparison. When we go for this, there is no need of parapet, walkway, noise barrier, everything is merged into these flanges of the U girder. There is no requirement of parapet, no requirement of putting railing on that. Everything is now merged into these webs of the obviously flanges of this U girder. Plus, one more significant saving was observed when we were using this U girder system, this box girder system. The rail where is to be fixed, it was basically at this level. When we have adopted this twin U girder, the rail level drastically went down by roughly around 1.5 meter. So this 1.5 meter was a good saving in terms of quantity of the concrete. And that is what I was talking about in previous slide. This quantity of the concrete was saved. So dead weight of the concrete entire structure was also saved. And so there was a reduction in foundation size, be it pile or pile cap or anything. So when quantity is saved, ultimately directly cost is being saved. So that was another advantage of using this U girder, apart from time saving and everything. We have also customized I girder, precast I girder into T girders, because I girder has their own challenges. Once you erect the I girder between two spans, then you have to use shuttering from the bottom or staging from the bottom to lay that slab over it. So again, to erect the staging, you need ground access. So in urban area, again, this is a challenge. So what we thought of, we have extended the top flanges of the I girder slightly more as compared to the bottom flanges, so that it becomes a T kind of girder. So the T is basically adjacent, two adjacent T flanges are basically being stitched together so that it becomes a slab, continuous slab. So nowadays, DMRC and other metros are also using T girder instead of I girder, which were being used in previous or conventional elevated corridors. Now I girders are almost obsolete. One more precast, I would say, or integration we have done when we were constructing Jaipur Metro. We were given the task of installing their metro system. So what we did, we constructed our metro system and also integrated the road flyover into the same column of same pier. This is a basically exact drawing which we have adopted there. The bottom of the first level is basically for road, and the second level is for the metro system. This also saved a huge. Otherwise, suppose if the metro system was laid first, or a flyover was laid first, then there was no space to run metro over it, or vice versa. So because of this meticulous planning or advanced planning or integrated planning, this entire integrated system has evolved. So these are basically these are actual photographs. You can see on the ground, on the ground level, road is moving, and in the middle level, another flyover is moving, on the top, metro is moving. So in total, there is a huge saving in terms of resources, in terms of time, and yes, it's a good saving in terms of environment and other things, because otherwise this road or flyover or metro may be running separately and maybe capturing more areas on the ground, disturbing more greeneries, more structures, and consuming more energy from the atmosphere and the environment. So this has become now a good case study. Now many other metros and many other cities are basically adopting this. Now we are also constructing the same system in North Delhi area, which is from Majlis Park to this Mojpur area. We are constructing this integrated system. Coming to the next structure, that is pier cap, just on the top of this pier. Earlier, we used to construct this pier cap by using in situ method, where we go at the side, we erect all this staging, shuttering, and we transport the concrete to the side, and we construct it. And then constructing of the pier cap was also challenging, apart from curing and other quality control aspects. So it was very time taking and space consuming. So we went for this precast technology, where we started constructing this pier cap in our casting yard. These are some photographs where precast pier caps are being casted, and they are stacked in a casting yard in advance, where when the need of these precast will be there on the ground, on the actual site, simply it will be transported through the trailers in the night hours, and then it will be stitched to the actual pier. So these are basically some photos which you can see. Stitching of this precast pier is being done with the existing pier. So simply we keep dowels open, and there is a central opening in the pier cap through, like here, through which concrete is poured, and both pier and pier cap is integrated or stitched. We have also used in previous phases precast eye girders, that is now obsolete. I told you earlier. Yes, this is that's latest technology of the structure which we are using in our system, which is basically U girders. These are the basically photos from one of the casting yards of DMRC, where we have casted all the U girders which are going to be used in actual viaduct. These are casted beforehand as per the requirement. This side you can see pier caps are there. This side U girders are stacked in multi layers. Nowadays we can stack U girders in 3 layers, so that we can optimize the space available in the casting yard. So this is the photo which is showing the transportation of U girder from the casting yard to the actual site where it has to be fixed or installed. Another photo of the same. Normally, earlier we were using 26-meter span length of U girder. Recently, we have extended it to 28 meter. We can now construct 28 meter length single span or full span U girder. That is pre-tension. You might have observed, or you might have seen or read somewhere. Bullet train is also. Yes.
Hello. Hello.
Yes, sir,
Yes,
you are
Sanjay.
audible.
Hello.
You can mute.
Hello.
I think someone wants to say something. Akhil, yes, please. If there is any query, please let me know. Otherwise, I am just moving ahead.
I think so. The mic was unmuted by
Okay.
mistake, I think so.
Okay, thank you. Thank you. So, what we did, we saved a lot of time and quantity of the resources like concrete and everything in construction of U girder, but erection of U-girder was again a challenging task because every location we have to mobilize these two cranes, and then we have to transport the U-girder to its location, actual location. Then from there, it has to be lifted and placed over to the pier caps. What we did, we thought of using the launcher methods, auto launching methods. So we explored, we found that China is having this kind of system. So we brought two auto launching machines like this. You can see in the photographs. What this machine does, this machine actually travels from pier cap to pier cap. There is no requirement of going on the ground and supporting and placing the cranes and lifting the girders from ground to the top. From the back side, machine can travel from one pier cap to another pier cap and so on. From one location, you can simply feed the U-girders, machine will take it and it will launch to the next subsequent pier caps. There is one transporter, you can see in the photograph, there is one transporter which actually runs on rail. It's like track will be laid for this transporter of the U-girder. It will come and collect the U-girder, pick the U-girder from the feeding point, and it will transport the U-girder to that location where the launcher is there. It will feed the U-girder to the launcher, and then launcher will launch the U-girder on the pier caps. This machine which we have used in two projects, it appears to be very fast. So in construction of U-girder, we also save time. While erecting also, we have saved by using this method machinery. So altogether, U-girder appear to be very, very, I would say, effective, cost-wise also and time-wise also. And yes, U-girder, since it was constructed in casting yard, so build quality was much more better than other methods, other structures. This is the old structure, or we say conventional structure, which was being used earlier in metro system. This is basically segmental box girder viaduct system. Now it is almost obsolete in metro system, which was using precast box segments. It was to be transported to the actual site, and every segment was required to be lifted by this blue launcher. You can see every segment after lifting at its position, then it has to be post tension, aligned, glued, and it takes around 4 to 5 days to build one span of around 35 to 38 meter. Normally 37 meter was the standard span length when we were using in DMRC. But in the case of U-girder, in single night of around 8 hours shift or 6 hours shift, we can launch, if machinery is ready, we can launch up to 2 span. So it's very quick, very fast. So that is why U-girder system is very now popular. As far as the station area in the elevated corridor is concerned, we are also using many precast structures in station. Earlier, these precast structures was not there in the station area. We were constructing earlier this entire station like RCC frame structure. You all might have seen in this particular photo also, you will find there is a central column in the station, and then all on the either side of the station, there are 2 column lines are running. So this particular location is in Rohini area of Delhi. You will find there was 2 roads. One road was here and another road was here. And in central portion, we were constructing our viaduct, and there at this location we have to we were required to construct a station. So on the sides there were footpaths were running. You will not believe entire footpath was damaged because the columns of this station was to be constructed, and beneath one column of the station there was 5 number of pile foundations. There were five number of pile foundations on each side. So entire foundation was constructed on footpath. Central portion was on median. So no, it was very time taking, space consuming. So what DMRC did, DMRC has did brainstorming and adopted precast structures in stations also. Now what we did, you can see in the next photograph, central columns are still there, but it is slightly sturdy and bulky as compared to the previous one. but now the side columns are now deleted. Only central columns are there. Up to here, these columns are casted in situ, and from this joint till subsequent height, these heads are actually pre-casted. Pier portion is also pre-casted, and the top, these pier caps and these pier arms are actually pre-casted in the casting yard. Once these pre-casted pier arms are transported to this location using post-tensioning method, using strands and cables, these are stitched and strands are basically stretched with the columns, and to make it like a you can say like a viaduct system. And then from each pier column to each pier to next pier, we have to fix the T girder and pi girders. You can see we have constructed precast pi girders. You can see in the image, these are having cross section of this girder is pi kind of things. So in particular elevated station, if you see, there is a platform, and then there is a concourse where you buy the tickets. So at platform, we have placed this pi girder on each side, so you can simply have one platform slab where you can stand and board and deboard that metro system. Even in this pi girder, you can see there is a RCC gutter is also precasted. So entire thing is precasted now. Almost every structure of a station is now precasted except the central column up to this height where pier arms are being connected. These columns are still casted in situ, including foundation. Normally pile foundation are being used. Rest other structures or components like these pier arms, these pi girders, these girders, everything is precasted now. And the top roof portion is prefabricated steel structures. So station is also using many precast, I would say more than 80% structural elements are precasted now in elevated corridor. It has saved a lot in terms of cost, quantity, and time, as well as less disturbance to the existing flora, fauna, and structures and everything, and thus less emission of the dust, noise, and carbon dioxide as well as. So these were the precast techniques and structures which were adopted in elevated corridor. Earlier, I have talked about the precast structures in underground structures. Now let's have quickly a view or overview of the precast track structures which we are using. Now tracks are also being used by being constructed by using precast techniques. So the first, this collage of the photos is showing the conventional method of track construction of metro system. Like on the deck slab of the elevated viaduct or the tunnels, we have to fix the reinforcement, install the shuttering, and then pour the concrete by sending the concrete through pumps or simply by moving the transit mixture on the viaduct itself. And then we have to carry out the curing, wet curing. And believe me, doing curing along the linear project, it's very challenging. So quality of the structure, ultimately entire life cycle of the structure is very not that much, I would say, in control. So this was basically the method which we're using in metro system typically. Still, most of the metro system are using this method. This is basically in situ method of track construction. But now I must say in the country, precast tracks method is also available. The one method which is already used and in operation, that is used in RTS project, which is connecting from Delhi to Meerut. There, this for slab track system has been used. Basically, it was a precast slab of 4 meter by 2.4 meter in size that was casted in casting yard and brought to the site. Simply, it is grouted with the shear keys already provided in the track slab, deck slab, and then rail is fixed with the clamps and the grooves which is there in the precast slab. So this method is also already used in India. Many more metros, including DMRC, is also planning to implement this method in track structures. These are some photographs of construction of precast slab track in factory in casting yard. You can see reinforcement is being fixed in the mold, and these are the structures. Precast slab track is there, and entire fastening system is fixed, and it is being laid in one of the tunnel of the RRTS. Pouring of the grout concrete, flowable concrete, self-compacting concrete is there to grout or stitch the precast slab with the uh, bottom inward slab track of inward slab of the tunnel or deck slab of the viaduct. Then final track survey, everything is done. Recently, you might have seen country is building bullet train for high speed track. Where basically bullet train is being constructed at a speed of 350 for the speed of 350 kmph. They will be operating around 320 kmph. And just to give a brief perspective, the previous corridor which I have just mentioned, this is RRTS. This is basically designed for 180 kmph. This system will be operating on 160 kmph, and the all other metro system in the country is designed for 95 kmph and being operated or will be operated by on 85 kmph only. So you can see the difference between the speed domain also. Metros are not basically for the speed. Metros are for the connectivity, better connectivity. That is why metro stations are very closer, roughly around 1 and 1.2, 1.5 kilometer. But in case of regional transit system or high speed, you will find speed is the major criteria. We have to save the time. Okay, so that is why huge speed is there, and accordingly structures are adopted. So coming back to this high speed track, of bullet train is also being constructed using precast technology. They call it as a J slab track system. It's basically Japanese slab track system because Shinkansen trains or Shinkansen technology is being used. So here precast slab track almost similar to the earlier one which I have discussed, just being used over the existing viaduct slab. So entire thing is precasted and it is being simply fixed with the viaduct slab using sear key and pouring the grouting concrete. There is one more innovation which is in being discussion in DMRC. We are planning to install solar panel on the viaduct footprint also. Though we have already used our station footprint and depot footprint along with other offices premises, everywhere you will find these solar panels. We are generating more than 51 megawatt solar energy from our footprint only. So we are planning to fix this kind of structure on the viaduct, and above that structure, a roof structure, will be installing solar panels also. So in nutshell, if we summarize the benefits of this precast technology in terms of sustainability, it appeared beneficial in many ways. Like one is reduce on-site environmental disruption. I have highlighted it many times when I was discussing underground section and elevated. On-site environmental disruption because of adoption of this precast technology has reduced drastically. So in case of using U-gutter also, overnight we can erect around 2 spans as compared to other conventional girder like box girder and other things. It takes several days. And yes, because of this precast techniques, we need less formwork, less shuttering, and less wastage in the process. That is why we can reuse the formwork. That is the good attribute of the sustainability. Mostly in precast techniques, we use steel shuttering. In case of in situ casting, mostly we go for wood shuttering. So there is in our contract documents also, it is specifically mentioned there is no requirement of wood and plywood shuttering in case of precast techniques. So reusage is also ensured through like this. And thus, when we are creating less, when we have less in situ activities, so there is a less noise, less site traffic hindrances, and less space acquisition, and thus less dust production and everything. So that is how it is basically ensuring the environmental integrity. And yes, because of this precast technology, quality of the structure is like anything. And once quality of the structure is ensured, so I must tell you, we are designing and constructing MRTS structure for around 100 years and 120 years for non-coastal areas and around 80 years for coastal areas. So the span, the horizon, life horizon of these structures are very long. It will take generation to be basically next many generation will be using these structures. To just give you perspective and example, London Tubes as on date is crossing around 163 years of its age. So you can imagine the type of structure or the methodology which was adopted at that time. Now they are also serving in the present time. With obviously with this with certain retrofitting, certain good I would say rehabilitation of the tunnels and everything. Yeah, those structures are still serving. So once you adopt this kind of methodology like precast technology, better quality control, where better quality control is there, so you can ensure the durability of the structures also. So you will have good long life cycle, a longer life of the structure and less maintenance. We have to think about the maintenance cost also. While we are going for the selection of the structure, we every time we need to think about the maintenance cost. Sometimes what appears by the planner, designer, or the executing team, they sometimes because of the lack of experience and the, I would say knowledge, they uh, think about the reduction of the capital cost or installation cost. They miss somehow uh, the aspect of maintenance cost in the overall life cycle. So life cycle in if you consider the life cycle cost, maintenance cost is going to play a huge role in it. So in that sense, precast technologies appear to be more and more cheaper. So that is our takeaways from previous experience of previous works. So for tunnels also, by using precast tunnels, rings and everything, precision construction can be done. Wherein in situ construction, precision construction is very challenging. I must say that thereby, yeah, tunnels are prone to leakage and frequent repairs. Obviously, resource efficiency in other aspect, all those resources which are being utilized, like in case of construction, we use huge amount of cement, steel, aggregate, sand, and everything. So when we go for conventional RCC, we all know it needs much more amount of the quantity of the resources as compared to the precast. When we go for precast, section of the precast concrete becomes more lighter and thinner. So obviously there is a huge saving on the quantity and the amount material quantity also. So resource can be effectively utilized. With optimum resource we can go for the construction. And there is one more aspect to this sustainability. Recycling of construction and demolition waste is a very good aspect. Well, when we do these construction activities, there are lots of uh, demolished material, be it concrete, be it any other. And sometimes when we use concrete for the production of the precast or in situ structure, there are some surplus concretes also. So those material are required to be effectively planned to be recycled for further usage. Not in that same structure, maybe some other structure, small scale structure like brick making of bricks and making aggregates. So DMRC is already doing this. DMRC has set up its own recycling waste plant, CND based plant. Around 150 ton per day we can consume. So this is a good area where we are actually ensuring this sustainability. With the uses of this precast structures, we can make our construction process faster. And when our construction processes are faster, the emissions of gases by various machinery which we are using, and if we are reducing the quantum of the concrete materials, so ultimately indirectly we are also reducing the quarrying quantity, quarrying load on the quarries from where we are procuring the cement, from where we are procuring the aggregates and everything. Indirectly, there is a lots of saving on the emissions of the gases also, especially the greenhouse gases. So in nutshell, precast techniques can save much more over these areas also. One more thing in the second point which is mentioned, once you install metro system in a faster manner, and let's say if you adopt conventional method of construction, conventional structures, so it may take much more time as compared to precast. So it means your station or your line is going to open at a later date. So it means public is not going to shift from the private vehicles to your public transport system. But once you use precast techniques, you can open your line at beforehand. So it means public is motivated or encouraged to shift from their private vehicle to the public transport system. It means if there is a less private vehicle on the roads, it means there is again overall less emission on the to the atmosphere. So this is how one more direct indirect benefit is there. Again, standardization and scalability is there with the precast. We can scale up if section and the span and everything is standardized. We can scale it up at any quantity, at any number of amount. If everything is fixed, like for example, if we have fixed like every U girder which is going to be constructed, it will be of 28 meter. So in the casting yard, we don't require formwork or shuttering for different length of the U girder. We can simply standardize, and for span less than or more than that 28 meters, we can have different kind of precast structure like three girders. What we have done is for 20 less spans having less than 28 meter, we have gone for three girders, and for more than 28 meter, we have gone steel structures. So that is how things can be standardized, and accordingly scalability can be ensured, and ultimately it will lead to the sustainable practices. So yes, once it is standardized, cost can also be, or wastage can also be avoided. So in nutshell, I must say, using these precast techniques, we can also ensure production and resource efficiency using waste reduction, lower material and energy consumption, using recycled materials for the subsequent auxiliary construction structure like construction of pavement, everything. We can enhance the lifespan of structures, its durability. We can lower down the maintenance by using these precast techniques. And yes, we can ultimately enforce a healthier environment by reducing the greenhouse effect gases, and enhancing air quality, and reducing the dust quality also, dust quantity also. So that was all from my side. I hope I made some sense. Now I will open this forum for queries. If you have any queries, I would be happy to answer. So I was told that around 15-20 minutes we have to discuss or on these aspects. So yes, I'm now open for the queries if you have.
I think so. We have some questions in our chat box.
Yeah,
So,
please.
Dr. Bharat Bhushan Jindal sir has asked how the metro route was decided, as most of the stations are situated in populated regions.
Yes, okay. First of all, I must say it's a very good question. So, see, metro system, metro stations and alignment, location of the metro station and its alignment. Alignment means its curvature and everything is actually governed by the trip generation concept. There is a concept called trip generation and trip survey, passenger survey. Basically, what we do, our team goes to the site, to the ground. They interact with the commuters who are basically office goers, or they are going to some, let's say, industrial area, some other locations. They interact with them. So we ultimately found it out that where trips are being generated and where the trips are actually being terminated. So the locations where trips are being generated, these are basically nodes. So at this location where trips are being generated, we have to fix a station. From there, we can collect the commuters to and motivate them to basically choose public transport rather their private or we say self vehicles. So that is how ideally the location of the station is decided. But there comes another challenge. Suppose there is a location where, as per survey, station is to be built on that trip node, but there is a physical challenge. There is some, let's say, some defense land is there or some other structure is there. So then in that scenario, we can shift station slightly in any direction, and then we can provide some connectivity from that location to this. Like for example, there is a location in Durgabai Deshmukh in Delhi area. That station is integrated with the airport line through travelator kind of things, or through FOB we can connect. So this is how it is governed. I hope I made some sense. Ultimately, it is not arbitrarily decided.
Okay, sir. There is one more question by Mr. Akash. What alternative materials are used nowadays in precast construction in order to reduce the carbon footprint?
Okay, nice, good question. As on date, you might have seen there is a buzzword going on: ultra high performance fiber reinforced concrete. So uh, till now, as I'm talking, till now, conventional precast, pre-stressed concrete technology is being used, wherein RCC is the simple concrete is there with other admission and everything. But now, in one of the project, we have mandated that contractor has to construct the structure by using ultra high performance concrete, where aggregate will not be there, right? There will be fiber reinforcement, reinforced fiber will be there. And ultra high performance concrete means concrete having characteristic strength or target resistance more than 150 MPa. So now we are going to use that concrete in metro system, but that concrete is already used in one of the NHI project, highway project in Pune area, and some of the locations, other locations also. So that is update in that sense.
Okay, sir, means we can say that we have started using powder concrete in metros also.
Yes, we have mandated in one of the recently we have awarded one contract to RVNL, Rail Vikas Limited, that is 12-kilometer elevated line. In that, we have mandated that ultra high performance concrete girder to be used, and those girder will be having span more than around 50, 60, 80 meter. We can have a girder of span more than 100 meter also in that sense. So there, no conventional concrete will be there.
Okay, sir. So, sir, there is one more question by Dr. Dada Patil. He is asking, what about using internal curing technique for precast elements? It will save water required for external curing.
Yes, I must say, as on date, we are using three methods. One is obviously the conventional wet curing method, which is not that much, I would say, energy efficient or in terms of anything. And we are using steam curing method also, for especially in case of tunnel, precast tunnel segments. We are using curing compound in curing of tunnel segment. After steam curing, immediately we are applying curing compound also, then slightly for 1 or 2 days for wet curing also. As on date, we have not used another internal curing compound curing method. Maybe it has not proven track record in terms of bulk concrete construction. But in case of building construction, we can go for this kind of methods. I don't know. It is not seen yet in the metro industry or in the bridge industry. I hope the participant who is asking this query, he can also add.
Okay, he has added that curing compound is useful only for surface.
Yes, yes, yes.
Am I
That is not
audible?
internal.
Am I audible?
Yes, yes,
Yes,
please,
yes.
please.
Yeah,
Please.
yes. I'll not take more than 2 minutes. Actually, I had done my PhD in internal curing only. So
Okay, great.
actually, internal curing means it's different than this curing compounds, because curing compounds will decline the evaporation only through the surface.
Yeah, correct.
Whereas internal curing means I had used the wet lightweight aggregates. I had made it wet for 24 hours or 48 hours, and then I
Nice.
replaced sand partial by that, and I used some polymers, so which reduced the this one, and I could develop up to even 66 to 2 megapascal, even 65 megapascal without curing. Even
Great,
I
great.
had kept the cubes under the direct sun also. So maybe, as you rightly said, sir, that on the bulk still it is not that much popular in India. It is
Yes,
only confined to some academics, whereas in USA and all, already it is being used for highway works and big works where really the external curing is a problem.
yes,
Because we
yes.
know that 1 metric cube of hardened concrete needs 3 metric cube of water, which is
Correct, correct.
really unsustainable. And more importantly, the external curing supplies water only to the cover concrete, 40 to 50 and
Obviously, it not,
inside, it doesn't go inside. So that is what I
yeah,
wanted to add. But
correct.
very nice, sir. Very nice. Your talk is very nice. Thank you. Thank
Thanks a lot. Thanks a lot for putting this information for everyone, including me. I must say, yes, as a country, we are very conservative, I must say. And that the still earlier, I was just before this query, I was talking about ultra high performance concrete. I must say, this technique is not new. It is 46-year-old technique, which is there already being used in USA. Now it has taken pace. So soon, I must say that Dr. Dada Patel has mentioned this internal curing will also take up pace when, because it is already being used in USA. So I don't know why industry is very conservative. Our country, our thought is very conservative. So
And
that
sir,
is why.
and economy wise also it is quite affordable, because I use those aggregates, and
Good,
even
good.
those polymers are quite affordable as compared to the labor and the cost involved in water. It's quite affordable. So
So I must say, Dada Patil ji, you must visit or you must share your this research so that I can convey to our top management so that we can start at least putting in some of the contract conditions so that industry is bound to use or some in some of the structure so that slowly it can take space or somewhere in the industry.
yes, sir,
So
sure,
like
sir.
we are the first in metro in out of those 33 metro, we are the first to put the condition in the contract for using ultra high performance concrete. Otherwise, nobody is, I would say, daring to use those words in contract conditions. Otherwise, how this industry will adopt?
Yeah,
Otherwise,
yes, correct.
it will remain in academics only. So
Yes,
yeah,
yes.
thank you. So
Very nice talk, sir. Very nice talk.
thank you, thank you. So we can move for the next query.
Yes,
Sir, one question from my side, Dr. Nakul Gupta here.
Yeah, yeah,
Sir,
please.
while talking about the ultra high performance concrete, as we know that it is able to give very high tensile strength also.
Yes, yes, nice.
So, was there any reduction in steel done on the side or on the
Yes,
project?
yes, 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 yes. True, true, true. Actually,
Because due
what is
to
happening because of, yeah.
Yeah, because due to corrosion, especially in Delhi NCR region, due to our this pollution thing and all carbonation effect, I think so. Our biggest enemy has become this corrosion thing.
I must tell you, there is no need of, I would say, steel. Are you able to get it?
Yes, 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 sir.
Ultra high performance concrete is something which is already using a fiber. Microfibers are there, and there is a USF. There is a SFRC also, steel fiber reinforced concrete, and there is a ultra high performance concrete. Those two are different, and these two concrete don't use steel, convention reinforcement steel in the structure. Since convention reinforcement is not there, there is no requirement of providing additional cover, and that is why additional deadweight is gone. Because there is no
Yes.
continuous reinforcement in the structure, so it can be more durable. There is no problem of the corrosion because there is no continuous steel. So it's a good domain to research or to get information about. So we are trying with this kind of structure, this material in one of the section. So we are yet to see the this implementation challenge. But no, country is already using. There is no Indian code available. We are following, I think, French code for that. And MORTH has given some guideline. MORTH, Ministry of Road and Transport, and RDSO, this Research Design and Standard Organization of Railways, has given some guideline for using USFRC, ultra high performance reinforced concrete. There is no code as on date, and there is no
I
steel
think,
in it.
and I think so. What we can do is, apart from using steel fiber in it, there is one organization known as ISDA. They are related to stainless steel.
Okay,
So in coming future, we can use stainless steel fiber also, because it
maybe,
does
yeah,
do not corrode. Plus, it has a 95% of recycle value also.
correct,
So
correct.
in future, we can use that thing also.
In fact, steel fibers are being used in steel fiber reinforcement concrete, SFRC. Steel fibers are not being used in ultra high performance concrete. Ultra high performance concrete fibers are of some other material, like they are some polymer, something, some nylon, something. They are not steel
Okay.
actually. So I will
Okay.
share the literature also. I have that literature, and there is one company called Longspan India, Longspan something. It's a Pune-based company. They are supplying these structures.
Yeah,
So you simply order it. They have precast factory. They will supply the girders of customized girder for your need.
yes, sir. On UHPC India also you'll get a lot of information.
Yes, UHPC India. Yeah. So I hope someone
Yes.
is there.
Yes.
Doctor. I best forgot the name. UHPC. He is
Dr. Dada
basically.
Patel.
Yeah. So he is basically founder or something of that MD or something of this company. Recently, we invited him in our academy also.
Dr. Satish Jain. Dr. Satish Jain.
Satish Jain, yes.
Dr. Satish Jain, I know.
Correct. Dr. Satish Jain. So he's the person. So it's a
Sir,
good
relating
forum.
to this, what Dr. Nakul Gupta, he's spoken about the requirement of ultra high performance concrete. When you are talking about the segmental box girders, you mentioned about the post-tension pre-stressing and the pre-tension pre-stressing.
Yes.
So therein, I think his question is quite relevant, because when you are already in fact pre-stressing it, so
Yes.
therein definitely the requirement of steel would certainly would have to be in fact reduced.
In the section of that structure, there will not be
Yes.
any requirement of the
Because as
steel.
far as the property of the concrete is concerned, it is going to behave in the manner in fact which is supposed to be done. But
So-
as far as the tensile in fact strength is concerned, there in fact the steel, it does in fact has to play up.
Yeah, actually, in case of ultra high performance concrete, what is happening, because of this fiber distributed across the section, this fiber is inducing more tensile strength to the concrete. So tensile strength of the concrete, which was very nominal in case of earlier precast or pre-stress or the simple RCC, it was nominal.
Sir, is
So
it relating to the tensile strength or the flexural strength against the cracks?
tensile and flexure both, I must say.
Okay.
So actually, this USFRC is UHP ultra high performance is not in situ concrete. It's a precast technique. In precast, what we did, conventional RCC segments are now replaced with the ultra high performance segments. So there is no reinforcement. So that is how it is working on it. The principle
Sir,
is that.
Fair enough, sir. I think you replied to the question. Sir, relating to the project management perspective, can you please, because there have been certain accidents which have happened in the country. There are certain, what are the key challenges in coordination with regards to the casting yard operations, then the segment infra transportation, and on ground in fact, so how is it, how do you in fact, what are the challenges which have been faced by DMRC, and how do you in fact circumvent such in fact occurrence of the accidents or the incidents?
Yes, it's a good good practical question, I must say. First and foremost thing is the crisis of I will keep it on top, crisis of skilled manpower. First and foremost thing, skilled manpower.
Yes.
When I say skilled mason, skilled foreman, bar benders, and the skilled site engineers, we don't have as on date. Everybody will realize, will coincide with my statement. This is a huge crunch crisis this country is facing right now. Many leaders, even L&T MD has few months back has shared, they are facing this issue. The first thing is that. Second thing is the safety with the dealing with these bulky structures. As a country, we don't pay much attention on the safety aspects. Like we pay attention on the morals in the education. So we don't pay much attention on the safety. What we did, what nowadays we are paying attention on to cutting the cost and time, to cut the cost of the project, cut the time of the projects. But we are compromising with this kind of safety and everything. So what many recent accidents in even including DMRC, unfortunately, attributed we can
Sir, I think
attribute these.
I'm sorry in interrupting you here. Can you
Sorry.
please relate to the case study, like in fact what happened in Calcutta, wherein in fact the entire segment actually it came down, and it was again in fact a crowded situation as what we have in Delhi. What
Yes,
exactly happened, and what could have been done to avoid that?
actually premature, I would say, erection, when the structure has not taken its initial strength, loading that structures to the actual full load while stressing. This premature stressing is very dangerous. In case of precast techniques, especially in box girder, in case of pre-tensioning, we cannot. I would say if you go think about the pre-tensioning, it is in the yard.
Yes.
Okay,
Very
but
correct.
in case of precast post-tension, it is on actual site, hanging right above the, I would say, moving traffic. And if it is premature, the segment has not achieved its strength, and you are
But
stressing.
don't you put it on the pier?
Yeah, we put it on the pier, but there is a launcher on the top which is holding during that time of stressing, and if something goes wrong, entire structure, entire pier cap, and entire launcher will come down.
Yeah.
Recently, many case studies, many cases accidents have happened in railways, NHAI, metros, the Kolkata, where during stressing and during movement of the launcher, entire span collapsed. So
you can say it is a technical and as well as a human error, both.
One technical, which is premature stressing, and one human, which is moving the launcher from one pier cap to another pier cap, one column to another column.
Okay.
Many launcher has collapsed, including DMRC previous phases. In phase one, when we were constructing in Lakshmi Nagar and Jamrudpur, Lakshmi Nagar, that was the failure of the launcher while moving the launcher from one pier cap to another pier because of the I would say laxity at the part of the team which was there in the erection team. They were not aware that how much pins is to be inserted, and somehow they missed some of the pins, and entire launcher came down because of shearing of the pins, because load was on less number of pins and everything. So with the launcher, we have to be very cautious about the sequence of the activity in shifting the launcher from one pier cap to another pier. That is critical safety concern.
Thank you so much, sir.
Welcome. So,
Anil sir, I think so. You have answered quite all the questions, and I must say it was a very informative session. And I must thank you for means accepting our invitation as a speaker in our FDP. So
thank you
very
so
much,
much.
sir.
It was for me, or also it was quite enriching and learning from you all, especially Dr. Dada Patil has shared many things, and the last query we were discussing about the mishaps and everything. These are very practical queries. I must say, we all are good engineers. We don't have wrong intentions, but sometimes, most of the time, out of pressure of cutting time and cost, these incidents are happening. We are bound to overlook these processes and steps. And believe me, there is no shortcut to science and technology. If concrete has to mature in, let's say, 28 days, it will mature in 28 days. You cannot cut it to make it 27, 26 or so. So we have to have that thought at the backside. So anyway, so thanks a lot for bearing with me patiently. It was a good learning experience for me also. Okay, have a good night. Yeah.
Sir, I think so. Ajit, do you want to say something?
Yes, sir.
Please say the last word. Okay.
Thank you, Mr. Anil Patel, sir, for this engaging session on sustainability in precast construction technique in MRTS. Your insights drawn from leading projects and governance at DMRC are crucial for understanding how rapid urban development can achieve sustainability. Ladies and gentlemen, we have a successful concluded day second of the SIT sponsored FDP on digital construction and green design pathways to net zero. Today was truly informative, focusing on the physical building blocks of our sustainable future. In session 3, Dr. Sanjay Mundra showed us how decarbonization and circular economy in cement and construction are mandatory, providing practical solutions from his expertise at NCCB. In session 4, Mr. Anil Patel had then demonstrated how the adoption of efficient precast construction techniques in large-scale projects like the metro rail optimizes resources and drives sustainability in execution. On behalf of Institution Innovation Cell, NICMAR Delhi-NCR, I would like to offer sincere vote of thanks to all the contributors. Our profound gratitude to Dr. Sanjay Mundra and Mr. Anil Patel for dedicating their time and sharing their vast, specialized knowledge. Your contributing have been invaluable in bringing the gap between the academic theory and the industrial reality. Thank you for the ICT and Atal Academy for sponsoring this FDP and campaigning the empowerment of the technical faculty. Thank you the entire team, including our patron and the coordinating for their visionator for the vision. We thank our coordinator, Dr. Nakul Gupta sir, and the dedicated technical support team for ensuring the smooth execution of all session. Finally, thank you all the faculty, scholars, and the professionals for your active engagement throughout the evening. Your enthusiasm is the driving force behind the program. A final critical reminder, please ensure you have completed the attendance form given in the chat box for both session and 3 in the chat window. This is essential to meet the attendance requirement for your ATAL certificate. We eagerly await your return tomorrow, Wednesday, November 12, 2025 for the day 3, where we will continue to explore the crucial intersection of technology and sustainability. Thank you once again, and we look forward to our successful day 3.
Thanks a lot.
Please,
Thanks a lot.
please switch on your video.
Please switch on
Anil.
your camera so that we can have a group photograph.
Yes.
Okay, Ajit, is it done or not?
So done. Thank you once again, everyone. So good night.
Thank you, Anil sir.
Thanks a lot. Thanks a lot, Nakulji. Thank you. Bye-bye.
Okay. Bye, sir. Good night.
Thank you. Good night.